only one
Was it
couldn't
running?
find the lark, and then when she finds lark, she said not permission to join, but everybody else join. I don't know why.
The Windows icon.
Is it Zoom?
No, it's lark. Because I asked Kendall, can we purchase enterprise account for Zoom so we can take AI notes? She said, we're so poor, the installation. And so we cannot take the AI notes. That's why we use Lark. It's free to take AI notes.
Okay, we're not, we're too cheap to pay for the
It's
AI features.
$15 per month. Are
Per
we that
user.
cheap? Yeah. No, it's not by license, per account. Myself, for my personal one, I pay $15
Yeah,
per month.
for one user.
Yeah,
So the other has many accounts. So we have to pay for it.
it's your choice. Then nobody can blame us to use Lark because we don't, there's no enough volunteers to take notes for every meeting. This is the only way.
What kind of notes are you looking for?
Yeah,
Is that mine?
I mean, yeah,
I don't have what you're talking about.
And Malini is not able to join. She's a speaker. She said the Lark doesn't allow, she doesn't have permission to join Lark. I don't know what to do. Let me call her.
Or is she doing it online?
She, not COVID, but the sour throat.
Oh, okay, got it.
Can you just guide her? Can you call her? You have her cell phone, call her and guide her.
No, I don't have her.
I have her Lark. Let me call her
I
Lark.
have her.
She joined yesterday, but today she says just no permission. I just, I copy
I have
paste.
it. I have it.
Okay, call her. And let's run the digital,
Yes, I got no.
we run the digital MC.
No.
Yeah.
Hi, Malini. How are you? I know, that's what, Nina told me. Yes, what's going on?
Yeah.
Yeah.
What was the thing you were talking about with the notes transcription? I might have what you're.
We already have a lot, it's perfect. Because she asked why
no, I
not
asked
Zoom.
why we're not using Zoom.
Yeah,
She
because
explained that the
Yeah,
Lynx
but
Foundation,
she-
which I'm part of, did not
Well-
pay for the AI transcription features.
Oh,
Lark already has it.
yeah.
Our first presentation is from Moshe Shabman from Anylog, who will introduce us to EdgeLake and how it enables AI at the edge using a plug-and-play software stack.
No, I think,
Also,
It's
I think
wrong.
the wrong one, yeah.
huh?
It's the wrong one, yeah, I mean,
Did I the wrong one?
this is wrong one.
Okay, sorry. The
How am I
AI
supposed to
Okay.
present from here or
Either way,
stand there? I can
we
stand
wanna
there.
see your face, but it's not you, because our human AC played the wrong script from the AI AC.
So
Let
it's
me
not your
see.
turn yet.
No, it's not your turn.
Our first presentation is from Moshe Shabman.
Okay.
Is it wrong?
They
It's
insist
wrong
to have
one.
it.
No, 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 hold, no, no, not your turn.
I
Okay,
think something wrong with the map. Give me a second.
something wrong? It's
With the
not you
map.
yet, hold on.
So where do I plug it here? Or no, just go.
It's not
Yeah.
your turn yet, but if you really
There's an
wanna.
HDMI there.
Okay. So, okay, what should we do? Malini is giving, is supposed, look at the agenda, it's not your turn yet. Our MC played the wrong script from the digital
Oh.
MC. I'm so sorry.
No worries.
Yeah.
Just, I'm curious, am I supposed to stand there when I get? this?
Yes,
Okay.
when it's your turn,
All
stand
right.
there
And I can
or
use my
walk
laptop.
anywhere. This is, the stage is all yours. Yeah.
Stage is all mine. Okay.
Oh, yeah.
Is it something wrong for?
Yeah, try to share the,
Yeah.
I mean, that one, but, let me see, this is the one.
Welcome back to day 2 of the AI for Developers meeting. Let's kick things off with an exciting session on EdgeLake.
That's
So-
a correct one. Yours is actually? Okay. Because you guys keep changing the agenda. We just use the most latest version agenda to make the AI. Never mind. We know what it is.
FaceTime her and.
Question who? Malini?
I just
Okay,
raise her phone.
okay, just, I don't know. Yeah, maybe we start from you. I don't know. Malini today has an IT problem. Yeah. Go ahead.
Whatever.
Yeah, whatever, go ahead.
We'll start with a brief overview of the day's schedule.
See, that's a correct one,
Yeah.
right?
Yeah.
But she's not here. Okay,
So-
Marsha has been standing there a couple times. He's very eager to speak now.
Sure. Only. All right.
Dedication hours, business.
I think this one. The HD.
If, okay, it's up to you. We also download to the, where's the presenter's laptop? Do you want to use your own or presenter's?
I'd
laptop?
rather use mine because I have
Okay,
a
fine.
presentation.
Yeah,
That's it, no?
it's coming. Not yet. It's sharing, he says. Carlos not here?
I'll send my comments.
Don't have it
It's
on.
sent to Slack. Okay, let me go pick up people.
So, good morning, everyone. My name is Moshe Shadman, and I'm the CEO of a company called Day2. And we're the company behind a product called EdgeLake. So actually, there are two versions, the commercial one, which is called Day2, and the one that is distributed with the Linux Foundation, which is called EdgeLake. And I'll talk, I mean, some of you have seen the presentation, but I'm giving an overview of what we do, how EdgeLake works, and how it fits into AI, and how it enables managing of data at the edge. And at the end of the presentation, I'll show you a short demo. So we've got a setup with many edge nodes, and I'll show you how data is being processed using this platform. So maybe just a few words about the edge, and all of us are very familiar with edge. So I'll do it very quickly. So maybe the number one problem at the edge that there is too much data, right? So huge data volumes, and as engineers, as people that work with data, we know that even simple problems are very, very complicated when you have a lot of data. So that's the starting point there. Then, if we think about it, there is no existing technology that enables companies to extract insight from their data when the data is distributed on many, many nodes. So that's a major challenge at the edge. If we look at the edge, not enough compute power. If we bring the data to the cloud, on the other hand, you've got a lot of compute power, you've got very organized resources. At the edge, we've got Raspberry Pis, we've got switches, gateways, which is not ideal to build infrastructure platforms. Another very common problem is if you need to build something and you are on some edge nodes, this edge node most likely sees local data, but the problem is that there is a lot of data all around the node, which could be very, very relevant. And it is very hard for somebody that builds on a particular node at the edge to be able to interact with data which is not local. With all this setup, it's very hard to service the data in real time, which is one of the main goals of moving processing to the edge, is to be able to extract real-time insight from the data. That's lots of data is distributed and so on, makes it really, really hard. And maybe the last point that I'll mention, people move their data to the cloud because the cloud has all the data services there. So you go to an environment where it's very, very easy to interact with the data. On the edge, you're on your own. You have to figure out what to do, and pretty much you have to start from scratch. So that is the quick overview of the challenges and problems at the edge, and those are the things that EdgeLake is addressing. So I'll show you a platform that addresses each one of those things that I've mentioned. So at a very high level, how EdgeLake operates. So on the left side, you see the traditional approach, how data is managed today. And the way data is being managed is you've got all those things that generate data, and the data moves to nodes at the edge that capture the data. But from here, there is a journey for the data that starts at the edge and starts to pull the data and push the data from those edge nodes to the cloud. And when we set the data in the cloud, we know there are those databases there are all those services there that could manage the data, and only then the data could be serviced to the applications. So without going into the details, and again, I'm sure everybody's familiar with what's going on there, but we could say two things. One, real time is gone, right? This is not a platform to service real time. So all those real-time requirements, and especially with AI, when we need to extract real-time insight from the data and understand what is going on, that is gone. And the second thing is obviously the huge cost. So before we go to the details, this is what EdgeLake enables. This is a piece of software that remains at the edge. So all those edge nodes have EdgeLake deployed on them, and the data remains there. When application needs the data, it issues a query in the same way that it would issue a query to a centralized database, and it would be able to get the data right there from the edge node. So we could have hundreds of thousands of nodes, each has a piece of data. These applications see exactly what an application that works against the clouds is able to see. And it sees a database, which is, in this case, it's virtual, versus on this side today, you see a physical database. EdgeLake brings up a virtual database that represents all the data that is hosted at the edge, as if it is organized in a centralized database, although the data remains in place. And then an application could issue a query and get the result back. And the result would be identical to the result that you would get if you were to move all your data to the cloud and host it in databases there. By the way, if there are questions while I'm talking, feel free to ask a question. So let's see what happens on a particular node at the edge. Let's try to understand how that works. So let's start from some node at the edge that has some operating system, which could be virtual or physical. It could be, Edge Lake can be deployed on a small switch or gateway all the way to the largest server. And I'll talk a little bit about that. So we start from some box there. And then the next step is to deploy Edge Lake. I think it says here Anylog, but deploy Edge Lake on this node, and it's all Dockerized. We have strong partnership with Open Horizon, so you could use Open Horizon to deploy it, and there are other ways to deploy it. And then when you deploy Edge Lake Core, the next thing to do is to enable the services that you want the node to offer. So you can think about it in a similar way to the data services that exist in the cloud, but are missing at the edge. So this part, which is really a user or an engineer decision, what are the services that he wants the node to offer to the outside world? And those services could be services to host the data, store the data, could be local databases, to satisfy queries, to pull data in. So you could enable their service that would show to the outside world a message broker. So you could actually publish data on the node or send data into this node via REST. And on top of those services, there is another layer, which is hardware abstraction. And the goal of the hardware abstraction is to make all those nodes look the same, regardless if it's deployed on a switch, gateway, or a large server. So when you look at the node from the outside, you look at it through the hardware abstraction, which makes it indifferent what is the physical hardware at the edge that this node is deployed on. And then on top of the hardware abstraction, there is CLI. So every node comes with a default CLI and APIs that you could communicate with the node. So that's how each one of the nodes at the edge looks like when you deploy Edge Lake on them. So now we're going to the next question that somebody may ask. All right, so you're able to automate the data management on a particular node, but at the edge, the problem is that you've got a lot of nodes, thousands of nodes. How do you deal with it? And the answer is this. So let's take an example where this time we've got two nodes at the edge, and each one of those nodes is deployed with Edge Lake. There is another layer which is created in a completely automated way, which is a virtual layer that spans all over the edge. And this virtual layer is created in a completely automated way. So you don't need to do anything. It would be there by deploying Edge Lake on all your edge nodes. And what it allows the applications, what it makes the application do, it would service data from all the edge. So you could hit a single node. So let's say my application are using the APIs to this node here at the left, and they issue a SQL query. If there is data on a different node, which needs to be considered in order to satisfy the query, it would be considered. So rather than this virtual layer, rather than users interacting with individual nodes, what it makes is a virtual layer that allows users and applications to interact with the entire data set at the edge. All right, so let's be more practical. And I brought here today, one of our customers is a city in Kansas. And I'll show you a little bit of how they're been using EdgeLake to transform their city into a smart city. So, but still at the diagram level. So you've got PLCs that generate data. And the data goes from the PLCs into those nodes at the edge. So each one of those nodes has Anylog there or EdgeLake there deployed that is managing the data. And queries could hit any node in the setup. So we call the node that gets the SQL from the application, the query node, but it can be any node at the edge. It's completely decentralized. And this query node would transparently service the data to the application. So the communication between this node and the nodes at the edge is completely transparent. Users interact with a single node in the network, which would virtual the entire data set. So the application looks at it and see a virtual database that contains all the data that you got at the edge. And it could just issue a single query and get the result. So here is another look, another way to look at it. Although you've got a lot of nodes at the edge, applications don't see the individual nodes. They can if they want to, but they could also interact with the edge as a unified and complete set of data. So from here, I'll show you a few examples. So this is a live demo, so it's not a mock-up or anything. Those nodes here are some of the nodes which have Anylog EdgeLake deployed on them. And each one has data. So the data is distributed. There is no cloud here. There isn't any centralization. The data is distributed here. But nevertheless, and this is an example of, so some of those nodes were of this city in Kansas. So the city is called Sabetha, and they are using it to manage the city's infrastructure, electricity, water, and wastewater. So this is the generators, I think. So we didn't deploy it. It was deployed by a system integrator. But we could show some examples. So for example, if I pick this generator, this is real-time live data coming from the city's infrastructure. And you could put alerts on it. You could, Anylog has all those services to put alerts, to monitor, to service the data to the applications, whereas here it's being serviced to Grafana. I can show you more examples. So this is the wastewater plant. So you could see here different status of the wastewater of the city. And I can show another example, which is, I think, the water plant. So you could see here the water level and different statistics and different information that the city is monitoring and needs to view. But the thing is, there is no cloud here. There are lots of nodes deployed in the city. The data goes from the PLCs, from the devices, into those nodes at the edge. And that's it. No cloud, no cost. The first thing that the city did when they moved to production is terminate their cloud contracts, which is very interesting. So let me show you maybe a little bit of the details here. So this is a REST API, a REST GUI, something that we're sharing with users that are using EdgeLake. And it's like Postman, if you're familiar, you could send using this request into nodes in the network. And by the way, everything that I'm doing here, you could do using Postman. So it's just easier and built specifically for EdgeLake networks. And I'll pick a query. So the buttons at the bottom are buttons to that show different queries. So I'm selecting an example of a query, and I'm sending the query to the network. You can see here I flagged the network. So I'm not telling the query where it needs to go. So remember, we've got a few tens of nodes distributed all over the world. I'm issuing a SQL query, which doesn't tell the process where it needs to go. And when I hit send, the query goes into the edge nodes, or the data comes back from multiple edge nodes. And you could see the data here at the bottom. That's what the Grafana is doing under the hood for any applications, just issues SQL queries. And if I scroll all the way to the bottom, you could see the data came back from 4 nodes. You could see it here. And by the way, it says on the statistics section that the time that it took is 0. And the reason is it wasn't 0, but it was a fraction of a second. We don't print in this report fractions of seconds. So you get the data from the edge in exactly the same way that you would get it if it was being pulled from the cloud. But there is no cloud, there is no centralization. The data remains in place. And everything, by the way, everything that you saw here, including the work at the city and all those other use cases which are using us, was done without a single line of code. You just deploy EdgeLake and configure it. And you'll be able to interact with your edge data as if it's living on a centralized database. Yes, please.
I have 2 questions. The first question is a data protection issue. So how do you handle this input data in the edge node? How do you handle the single point of failure?
So there are 2 questions here, right?
Yeah, the first question.
Yeah. So security. This is more secure from the cloud, and I've got a separate presentation on that. But at a very high level, each one of those nodes that participate here has a private key which assigns the messages. So when a node gets,
I'm not asking a security issue. No, I'm not a private. Single point failure.
oh, okay, that's also a good question. Great. So the question was about single point of failure.
Yeah, single point failure. You have an edge node, your data. Once it fails, how do you handle it?
Great question. Yeah, so the answer is that data is replicated. So again, it's a separate presentation, be happy to do it. But when data goes into a node, you as the developers or the ones that have implemented it, determine how many copies of the data you want to keep. So if a node fails, the network protocol would route the queries into one of the surviving nodes. So that's part of the protocol. The EdgeLake network protocol would replicate the data in an automated way, the number of copies determined on the user. And it's something that is done in a completely transparent way. So you don't need to write code, you just need to enable the right service.
Yeah, then comes to my next question. So since you have a virtualization layer, which is disputed one, so then what is the requirement to the edge node hardware side? Because once you do the virtualization calculation, it's not a small job. So how do you handle that part for each edge node?
So yeah, so are you asking about scaling, how scaling?
The edge node requirement, what kind of hardware do you need? Because you do the virtualization, that's not an easy job.
Yes. So the virtualization is not based on the node per se. It's not the information that we leverage to do the virtualization is data that resides on a blockchain. So
you're using blockchain.
Blockchain, we use the blockchain to do the virtualization. Again, something which is completely transparent for the user. But maybe I'll say a few words about this layer. What this layer does, it creates a shared metadata layer, because at the end of the day, you have nodes in different places. And one of the goals here is to make all those nodes work in a very synchronized and unified way. And the technology underneath that enables us to do that is the blockchain technology. So the blockchain hosts the metadata, which is shared by all the nodes in the network, such that all the nodes, what it brings us to a place where all those nodes that without EdgeLake are independent nodes, they are actually operating in a very synchronized way, as if all the edge is a single physical machine.
Blockchain is a nice idea, but the thing is, once you use the blockchain, what would be the cost and the performance issue?
Okay. So we can talk about that. So the system is architected such that the blockchain, so I agree with you, the blockchain has a problem, right? The inclusion latency is unpredictable or it could be very long. But this EdgeLake is architected such that it has no dependency on the blockchain inclusion latency. And the reason is that when nodes operate, they operate on a local copy of the data that they need. And the synchronization with the blockchain is done in the background, so it doesn't have any impact on the insertions or the queries. So when you run a query, you are not dependent on the blockchain.
Oh, wow, nice product.
Thank you. Thanks a lot. Any other question? All right. So yeah, so thank you very much. There is another presentation, which I'm not sure if I'm doing or John is doing.
The AI character will tell us, we have AI character MC.
Okay,
He
great.
will tell us the whole thing, yeah.
Okay, sure. So thanks everyone.
AI character.
So
Yeah.
I'm doing.
You're not doing anything. Oh, what do you need?
So I'm asking John whether I'm doing.
So you're not done with the demo yet?
No, with the demo I'm done.
Yeah.
Continuing from the previous session, John Freyer from AnyLog will dive deeper into the workings of
So I
EdgeLake.
think I'm supposed to do it, not John.
Oh, okay.
Okay,
So because we can't keep changing the agenda, like, okay, never
So
mind.
I'll do it. So
I think the MC's sound is too loud for John, at least. She was scared.
Oh, yeah.
Not in my entire life. Shouldn't they?
Are you using the earbud to?
These are just blank.
Oh,
So
okay.
no.
okay. Okay, so I'm doing also this part of the presentation, and this is a little bit about work in the making. So we see EdgeLake as an enabler for AI, and one of the efforts that we're doing is with Tina's group, Infinity Edge. So I'll talk a little bit about the work that we're doing and why we are pushing EdgeLake to be an infrastructure that will enable AI at the edge. Okay, so I'll start with, the starting point is the slide that we talked about, how data is being managed today versus what EdgeLake is doing. From here, I would say that if we're looking at AI, and especially AI at the edge, right? So, for example, if we want to direct traffic, we could put a camera out there that would look at cars passing by, and the AI can determine whether to switch the traffic light or move the traffic left or right. It's very, I would say it's very requested or needed to have a platform at the edge that would do it. And then if we go back to the previous discussion, it's very complicated. So that's what EdgeLake works, EdgeLake provides. And now there are two things that I would want to mention in the context of AI. One is maybe a more conventional way, how EdgeLake could fit there and enable AI at the edge, and some very interesting work that we're doing with federated learning, and I'll try to explain why and how it fits. So the first thing is about data collection. So let's go back to the example in the city. You've got the city, they have generators, they're generating electricity, data comes through the PLCs to some edge nodes, and then you need to collect it, you need to host it somewhere at the edge. So again, instead of figuring out what to do, if EdgeLake is deployed there, you've got the service, it would host the data locally. Then with AI, you need to take all the data from the edge nodes and bring it to some digital twin or to some centralized database in order to be able to generate the model, right? So you need to centralize the data. And again, if you've got EdgeLake there, it's relatively easy. You could associate one node as the main node for this process, and it would issue a query to the edge for the data that you need, and you'll get all the data that you need right there at this node. And now you could run the process that would generate the model. With federated learning, that's not needed. So the idea with federated learning is instead of taking all the data from the edges and bringing it to some centralized database, the idea is that we would push the code that creates the model to each one of those edges. And on each one of those edges, this code would create a submodel, a model that represents the data that is local on this node, which means that we don't need to centralize the data. And obviously, if you have a little bit of data, it doesn't matter. But we're talking about use cases where there could be petabytes of data. This is a really hard thing to centralize the data. It could be also very expensive. Whereas if we got the data already on those edges, we could just create small models on each one of those edges. And then, so the model generation, if we're doing traditional AI, would be created on this node that we dedicated to bring the data, query the data. Whereas in federated learning, we could create those models at the edge. And then if we create the model at the edge, and I'll show you a little bit more details of that, if we create the models at the edge, now we need to bring the models to one place to create a unified and complete model. But this is relatively easy because there isn't a lot of things to move. We move pieces of code from the edges versus with traditional AI, we need to move all the data. And then the model distribution, we're using the blockchain, and again, it's maybe a separate discussion, but maybe connecting to what we've discussed before, the blockchain is a shared metadata layer, and whatever we publish on this layer becomes available to all the nodes. Think about the blockchain in this context like a shared drive that you could have against all your nodes at the edge. So, and we've got really simple APIs to let you write stuff on this layer, and then this information would immediately be available on all the edges. And from here, from here, once we've got the model on whatever method we're using, whether traditional AI or federated learning, we've got the model, so we could now use the blockchain to distribute the model to all the edges. And now obviously the model is being executed there to do the inference and to tell us the logic that we need to know in each one of those edges. So with federated learning, the claim is that in federated learning, this is done in a really simple way without the need to move the data. So I think there is a huge value for it, but EdgeLake would support both, whatever you want to do. So from here, this is similar slide. I just want to show. So you got the data at the PLCs and the sensors, whatever data source you're using, you're pushing it 2 nodes at the edge where it's being stored in a local database on each one of those nodes. And then you could dedicate a node, pick one of the nodes or have a dedicated node that will do the training by issuing SQL and pulling the data that it needs to train the model and create the model. This is by a way of data aggregator. When we got the model, we'll push it into the blockchain, right? And the fact that it's on the blockchain means that the model now is available to all the nodes at the edge because it's shared by all those nodes. And then from here, now the model could be executed. So let's talk a little bit more about federated learning. So federated learning is considered to be something which is hard to do, and there are different reasons for it. So I've selected some of those. So the first one is data heterogeneity. So if you have a lot of nodes, you've got varieties of data on each node. And one of the reasons to centralize stuff is so that you could have one place where you've got all the data and you could unify. Well, that's one of the things that EdgeLake takes care of because of the shared metadata layer. It would unify. So when you look, going back to the previous presentation, this virtual layer that creates one of the things that needs to be accomplished in order to achieve something like that is to unify the data. Although you've got many edge nodes, each one with a variety of data, there needs to be a mechanism that unifies it, so we take care of it. And then privacy and security is a big thing here. When you do federated learning, one of the interesting things that can be accomplished by federated learning, but also is a challenge, is that you may have parties that wants to contribute to the model, but they want to keep their data private. So EdgeLake would take care of it. You could let the models be shared, but the data remains private. And again, it's a separate presentation, and we could explain how that works, but it would also do this one. The next thing is doing federated learning or AI as a whole is very complicated. You need a lot of knowledge, very skilled engineers, where many companies don't have those human resources. And even if they do, it takes a lot of time to complete and deploy it and do it. And so EdgeLake is being built from the assumption that you cannot send engineers to the edge. No company would be interested to deploy databases on Raspberry Pis, to your point, deal with high availability there, and then deploy code that creates models and then execute the models. That's very complicated. And the goal of EdgeLake and what we're doing is completely automated. So rather than writing code, it's more of deploy, configure, and we call it policies. Express the policies that you want to leverage to maintain your data. And then again, when you look at the edge, it's a complicated environment. We talked about it. You've got distributed infrastructure, distributed models. You need to aggregate things. All of those things are being completely automated and kind of a plug and play using EdgeLake. So let's see how, let's see in the diagram how federated learning works. So again, same starting point. You've got the PLCs that generate data, two edge lake nodes that host the data in local databases. But this time, those nodes do the model training. So instead of doing the training in one centralized place that needs to bring all the data to make it local, here the data is not being moved. It remains on the edges. And then only the submodels that are created on each edge are being pushed into this model training node. But once they're all there, the models could be combined to create a unified and complete model. And then in simple, it's being published on the blockchain. And then, like before, it's being available to all the edges that this time are executing the model. And obviously, as a result of the execution model, you've got all the insights there, and you could change things so that you create different data, and then you could run it as a loop continuously. So we could see it here. So the first thing, the data is captured at the edge lake will do it. And then the models are being created on all the edges, and then the models are being aggregated, and then a unified model is being pushed to those edge nodes, and then they could do inference at the edge. And let's say the inference would say this time shut the valve if temperature reaches, let's say, 30 degrees. And so that behavior is being done almost in real time at the edge. And now new data is being generated. So you could create a new model based on the new data which is generated. And the idea is that this whole thing is fully automated. So just to summarize, I mean, we've got heterogeneous data. Edge lake would unify whether you're doing traditional AI or federated learning. Privacy and security is being managed. Very little skills. I mean, we try to do most of the things in an automated way. The main difference is with AI, traditional AI data is moved, whereas federated learning remains in place. And in both cases, we manage the complexity. So that's there. Again, we've got some of the pieces working, but not all of it. It's work in progress. We don't have the version of federated learning available yet, but I think that in a few months we'll be able to share it. And we're welcoming every input that anyone has, or if he wants to contribute. So that's, if you have any questions, be happy to take those. Yes,
I have a question. So, can you give us a real life example where, because I'm listening to you about the edges, but if you're going to ask a question that has to do with two edges, if the data is only on a certain edge and only the model is shared with all the edges, then it's not going to give you the complete answer, or am I misunderstanding?
So you're misunderstanding. Did you see my previous talk?
I walked in late. I apologize.
Okay, so I was talking about exactly on that point. So I explained the fact that there is a virtual layer. So Edge Lake, the number one thing maybe Edge Lake does, it creates a virtual layer across all your edges. And when you issue a query, you could bring the query to any node in this setup, any node at the edge. But this node has a layer on top of the virtual layer, and under the hoods, it would pull, it's a peer-to-peer network, it would pull all the results that satisfies, all the data that satisfies the query and present it to you as if the data is centralized, although the data remains in place.
I got you. What threw me off was when you talked about security, and what you said that there's certain, nodes that wouldn't want to share data, but you're saying that the layer would take care of security by the login.
Well, security is a big part of the network protocol. It's maintained at the network level. And again, I said before, it's a topic that needs at least an hour presentation, but at a high level, it's cryptographic. So every node has a private key, it signs it. So everything that is passing on the network could be validated. It could be validated that this request was being sent from the node or person or application that claims to be sending the request. And also with the blockchain technologies, we're also validating that he's permitted. So the fact that, you know, you are who you claim you are doesn't mean that you've got the permission to do what you're asking to do. So we take care of both of it. And again, it's a longer discussion, but that's also handled at the network level.
Thank you, appreciate it.
Any other question? All right, so really thank you very much, and I encourage each one of you who's interested in EdgeLake to reach out to us. I will be happy to help and support whatever you want to do. Thank you.
Break now or after?
Yeah, I think we can have a 5-minute break.
Yeah, we have 5-minute break and we come back 11:05. So come on, some of the music. Like you had Hashtag Wilson, like Taylor Swift.
Wilson,
Like,
we can try Marini's
Jennifer
thing
Lopez.
in this 5 minutes break if it shows here.
This is our generation, not Taylor Swift. Taylor Swift.
How's life in Madrid?
The AI model is really up to you. So we don't do so far. We are, so if you have an AI model, it's supposed to fit to any model. Your model needs the data, it needs the data in two places. And the devices and security can make it available. So you have, so you bring your AI product, if you will. Your AI product does two things. It needs to generate them all. And then it needs to execute them. So what, in order to generate the model, you need the data. So our product, although the data is on many pages, to make the data available, I live in the process that generates the model. And the second thing is once you got
We always, my kids go to school in UC Santa Cruz.
Yeah.
So they live there. So now my third son started college. I have 3 kids in UC Santa Cruz. No, we have 2 more. So the twins started there. Now the middle one, just today.
to train. You are able to, today, you need to take all your data and centralize it.
You're done sitting.
We can show you how to do it without your data.
Yeah.
Don't impact us.
It's separate, but still close.
Data is private too.
我就问他第二个问题是什么呢？这歌儿那当然了，你这个运营
首先我看上来。
是那样，大家不断的算，但算大家的这个要不那咋做的不就在这？那就得不断的咱几个人得不断沟通啊，那你咋知道啊？那就不算。不让这他不干这个事儿，不让这。然后呢，看他做的第二个讲解这个。那这个架构很有意思，但是呢，做起来不简单。我不知道他真落地要求。在 AI 支持下，它关键特别研究出来，那怎么做？因为他一旦做的是这个，对，就是那个，他是把这个东西上，但是还是得有。那我们去。放到那个。
Yeah, we talked last yesterday.
我不是玩不了，只有你我没有用，来口我不知道，我只是知道的基本都是我从来一直没看好东西好理论，但是我一直没找到一个好的一个就是我16年17年从 IPO 同样的会上我不是这个会上，我第一个问货币是一个国家的世界要对对我好好再说别人过来现实。
Phone was outside.
I know that.
What is your business?
I don't know that.
You don't know that?
This is like further than
What was that?
没有介绍，但是没有介绍，把你作为货币形式。Even you find the deep content，你想做货币。这个最朝鲜，他们知道。别的事儿都是怎么做的？
一会儿他来，你把他说，哎。
那你其实局部的东西，你就上不上就变好的，所以美元为你提供系统的经济，你不进这系统没法玩。
On the website, or if you email me, I could send you.
我对云是烧手，这个叫 cloud 啊 ，K-12 叫。
if you put your camera here.
麦克，对不对？麦克是吧？啊，我合让加。对对，咱可以加微信。那您坐哪儿？好，哇。
Yes, put my name here. No problem. Yeah. Just right there.
You brought up.
Do you want? I can show more.
Hey, Tina. You're not loving.
You can talk for a whole day, I know that.
Yeah, you're not loving.
黑板。
They cannot log into we're here to fix the problem.
Yeah, that would be better. You know, I can log in.
因为你要用 Alpha ID，你不能。Yeah, there's a confluence.
No, no.
Confluence general account. And
不是典型。
然后Ready, ready. Ready. 好，又有一个人搞不进那个 confluence，来，还是我们这个董事会主席前董事长。就是他们老师，你看 confluence 有个账号，对，他们老师登不进去。然后他讲塞纳，完全塞纳的没有。
这个点我们认为比较好。
他塞纳不了了。应该能去。
因为我平时我也不进，没有，也不是 first，所以就在别的专业
一定要白点。那我一定要把 ready 这个是好好
儿就跑了，已经财富自由了，不再迷路了。
So first they have Alpha ID. When you try to log in, they try to sign out. No button to sign. Your chair for LVI. He's not, he cannot fix this problem. Everybody has to go to ask Cato.
I'm saying fix. So now we cannot upload the slide. Yeah, because no login, nothing. You can browse in a different browser like. Oh, different browser, okay.
This is what worked for me.
Okay. The tips from the CTO of Dallas said different browser. You have other browser. Huh?
data break 火的不得了，就是因为联
它有个
Well, yeah, the thing is, you gotta have yeah. Yeah.
最后的问题还是按照data management。
It's about Alex Clark.
They don't support the hosting for
A lot of stuff online. Alex Carr.
We didn't do the beta before we launched.
Lives in a bunker in like New Hampshire.
there were some first
Yeah, like the time is very interesting. Like we have this big meeting. A lot of people they want to.
所以我们是说实话，我就知道
there's never we have to
because our next speaker was trying to ask.
我一直
Cannot use LID to log in. Because you're the only alpha people we can find in this room.
I'm telling you, I went to the States and we're about to be
So we're gonna bunker.
Lucky, must be a lockout. Like button somewhere, right? No, Peter. Like you're in the middle, like in the.
it's something with the browser because the URL is the same. The URL is the same, but it's a different server. So now the browser is sending the old cookies and everything to the new server.
I mean,
That means
So we're gonna.
they have to test all the browsers. If they don't, they shouldn't log in.
yeah.
This is a very simple, like, we have some.
Oh, really?
Not like the basic, not like the advanced.
I didn't expect it to be that.
So there's a spot I was talking
Yeah,
about.
very big. Okay. This is very experienced.
Oh, wow.
We all are. I mean, I couldn't figure it out for a week. I
As a
just-
CTO.
All right, so you let it go sour.
The sticky idea though is that it's not just that it's having the third, even having the stable eyes and having power and all that stuff. You need to go for AI 出版面啊，数据。Because let's assume that our handbag.
Next, Jerry Shao from Datastrato will present a novel solution to tackle data silos in the AD era.
You need to have a security.
Those are problems.
That can be solved on.
There you go. There you go.
The mic is, I think, on the.
Hello. Okay, thank you. Sorry for some problems that I cannot work in my laptop. So thanks for the invitation and it's a great honor to have a talk here. So as we all know that we have the data silo problems which is long-lasting and existing problem in the data area. But this problem becomes much more complicated when we move into the AGI era. And today I would like to introduce our new project, which is called Graphtino, trying to solve the data silo problems in a new way. So before start, let me quickly introduce myself and my company. My name is Jerry Shao. I am the co-founder and CTO of the startup company, which is called Day2. And also I'm a creator of this project, Apache Graphtino. And besides, I'm the committer and PMC member of Apache Spark and Apache member. And for our company, Day2 is a startup company aims to create a world's first truly federated, open federated metadata lake and trying to unify the data, analytics, AI, and operations across the clouds and to build a next-gen data and AI fabric. So let's start with some problems. First, let me walk you through a brief history of data management. And at the year of 1980s, the new technology, data warehousing technology, came out to try to centralize the structured data from different databases to a centralized one. This data warehousing technology will solve the problem of the single source of truth, can centralize the data and manage data in a centralized way and serve for the purpose of the BI and the reports, and also have some technologies like ETL technology to extract data from different sources. But still have several problems. One problem is the scale problem. The limitation, the scale is quite limited at that time for the data warehouse. Also, it can only handle the structured data. But when many large companies like internet companies like Google and Meta came out and emerging, their data volumes is much larger than the traditional enterprise company. Also, the variety of data has become more and more because of user-generated content. They have the images, videos, web logs, and etc. For this kind of the data volume and the data variety, the traditional data warehousing technology cannot well solve the problems. So a new technology come out as we call the data lake, and also with the coming out of the new open source technology, big data technology, Apache Hadoop. Now people are trying to transform from the traditional data warehousing technology to a new data lake technology. Try to build a data lake which can centralize all kind of data, no matter it is structured data, unstructured data, and semi-structured data, and building a centralized data repository. And on top of this data lake, we will have different scenarios like data science, machine learning, and report BI, and others. And we will use some specific tools and specific database for such kind of purpose. For example, we will have a real-time database for the report and BIs. So this kind of mixed with data lake and the specific data sets, and is becoming quite popular and plays dominant role in the current most of the companies' data architecture. But it still has several problems. So it can solve the problem of the scale very well because it can satisfy the scale like the super large companies like Google and Meta. But it still has several problems that data. You can see that data lake is just like a staging repository for the centralized data. You still need to copy data from one system to another system to fulfill the different needs, to satisfy different needs. So this copy or the moving of data from one place to another place will cause warehouse, they will introduce the data silos. Also will create the single source of truth. So maybe we can have a better solution. So can we just store all the data in the data lake, but with only one copy or several copies in the data lake? But we can solve the different purpose like BI, streaming analytics, data science, and machine learning. The answer is that when the year of 2020, the new technology called Lakehouse coming out, it combines the first advantage of the data lake and data warehouse, and using some new technology like Delta Lake, like Iceberg and Hoodie, which build a lakehouse format, trying to store the data in a lakehouse format and serve the different purpose. And you don't have to copy data from one system to another system for the specific purpose. So as you can see, the transition from the data warehousing to data lake and to the lake house. And the architecture, the goal of this transition of the architecture, so the goal is like to achieve the single source of truth, also can fully manage the data and get rid of risks, and finally will serve the purpose of data-driven business. So ideally, we can have the single source of truth or centralized data repository can solve all the problems. But the reality is that for the different scenarios, we still have several stacks to solve the specific problems. For example, in a company, they have several usage scenarios for data. One scenario is for the report, like monthly report, daily, monthly, or weekly report. They will typically choose some batch processing system, for example, like Spark, build on top of Hadoop data lake to try to run the daily job or weekly job to generate reports. And this is one scenario. And there are some other scenarios that we want to explore the data interactively. And we will choose to use some OLAP systems like ClickHouse, like others. They will also have their own stacks, include like their own storage, their catalog. And besides, we will also have some scenarios like we want to do some streaming analytics. So we will choose like Kafka, schema registry, and Flink or Spark to serve for that purpose. And besides, we will also a bunch of scenarios for the machine learning and especially LLM, some kind of listing, and we will have that stack. So as you can see, to solve each problem or to satisfy each need, we will have different stacks, and these stacks will have the like storage on the bottom layer and have a catalog or metadata management in the middle layer, and also have the like a processing engine on the top layer. And if your data want to serve for the different purpose, you have to move the data from one place to another place, or copy the data from one place to another place. You cannot using one copy of data to satisfy all needs. So the purpose of Lakehouse is trying to solve such a problem, but the reality is that the limitation of the current Lakehouse format cannot fully satisfy all the needs of data stacks. So we still need to copy, and this copy or this movement of data will easily break data silos, and you have to copy multiple copies of data, and it will lead to the data silo problems and break single source of truth. And this problem is a data problem, but data problems becomes much more severe in the AGI era, because the potential power of the LLM, so we can explain, or we can dig more from the data which we previously were not touched. For example, like email, like PDF, like Office docs, Excels, and PPTs, and PDFs, bunch of PDFs. Traditionally, as a data team for the company, they will not touch such kind of data because it is hard to get the insight from such kind of data or files. But now with the power of LLM, we can understand the content or get a summary from such kind of data. So the variety of data becomes more and more, and we need to collect data from many kind of sources. Also, we have the complexity of the management of data will be increased. Also for the LLM, they'll have its own stacks to build for the training, fine tuning, and inference. For example, we have for the LLM, they have a vector database. So you have to move the data, copy data from different places and inject into the vector database. So that will also lead to another kind of data silo and break the single source of truth. So as a conclusion, because we have the many stacks for each stacks to handle each province, and the introducing of the different stacks will easily introduce the data silo problem. That's the data silo problem is introduced by the data stacks. And another thing is that for many companies, they are now moving from the one cloud strategy or one region strategy to the multi-cloud, multi-region strategy. They have many reasons. Some reasons like avoid vendor lock-in or achieve the high availability, no matter which reason it is. So the thing is that this separation, this choice or this separation of multi-region or multi-cloud will by nature introduce the data silo problems because you cannot, it is hard to move data, centralized data across regions or across clouds because of the transmission cost. It is quite time consuming. Also, the cost of egress is quite high. So it is by nature introduce the data silo problems. And besides this limitation, also for company like they have the global business and their data is attributed across the regions or across the continents. So for that company, for different countries, they have different policies or regulations for data. So you cannot move the data into a centralized place to process or do the insights data. So this kind of is a limitation by nature introduce the data silos because you can never collect data. For example, you can not transfer data from one country to another country. So that's another problem is that due to the cross-region or cross limitation and due to the regulations and the data silo problem is also exists. So besides the, as I mentioned, like data silo problems is introduced by the different stacks or different region clouds like regulations. But for the data, we are not just access the data. We need to deal with data in different ways. So the problem is not just data access problem. We have to do the data discovery, data classification, data lifecycle management, enrichment, automation, and others. All these problems around the data, which we think that traditionally our data management architecture like data warehouse, data lake, and lakehouse can really satisfy such needs and can solve the problem. So instead of thinking this problem like a storage problem, we thought this problem like a metadata problem, not a data problem. So we think that this problem can be ended with a unified data catalog. So let me show you a picture again. As you can see, we have different stacks to solve the different problems, and each stack will have its own storage layer and its own metadata layer and its own query engine layer. And previously, like Lakehouse technology, it tries to unify the storage layer so that we can put all the data together and using the one format to solve all the needs. But the reality is, like I mentioned, it is hard to achieve, no matter is the limitation of the technology or limitation of the regulation. So let's move ahead to think about this thing, because each data should have metadata. Instead of unify the data together, we can unify the metadata together. So we can like build a metadata layer and on top of different metadata and presenting as a unified way to solve for engines. And different query engines and processing engines can talk to this metadata lake to get the metadata and to know to know whether the data is actually where the data it is and what data it is. So with this kind of metadata lake layer, so we can solve several problems. First problem is that we can have a whole picture of the data because we manage the metadata of the data as a whole. Besides, we solve the problem of single source of truth from the metadata layer because each data should have a metadata, so we can unify the metadata to solve the single source of truth problem. Besides, because we build a unified layer on top of different data catalog, so we can provide the centralized governance features like security, auditing, and others. So we think that instead of trying to unify them in a storage layer, we think that unify them in a metadata layer to build a next-gen data catalog is a core in the new open data architecture. So with this brief, we build our new project, which is called Graphtino, which is trying to build a unified metadata lake across the regions. So Graphtino is a unified metadata layer on top of different metadata sources. It can manage data from like data lake, data warehouse, files, and relational database, and models, and message queues. It has a unified accessing API and build a unified model on top of this. So no matter it is which table it is, no matter it is Hive table or iceberg table, you can access with a unified way. Also, we have Graphtino is a multimodal metadata model. It not just only support like the tabular data, it can support unstructured data like files. And so you can access the files no matter it is in HDFS or S3 or others. And besides its unified accessing and unified model, Graphtino also provide a unified management. You can manage the metadata. For example, like you can create a table, load a table, create files, and create a topic, and with a unified way. Also, you can do the unified governance, like you can tag on the metadata, and you can do the search and do the audit and do the access control, and you don't need to touch the underlying sources. We provide a centralized way. And besides this, Graphtino also is a federated architecture because we want to solve the problems across the region or across. So it is built as a federated architecture. One Graphtino can talk to the Graphthinos each other, and so they will have the whole picture of the metadata. Now, when you access one Graphtino, it will try to understand if it has the metadata or its peer have the metadata. When it doesn't have metadata, it will route the request to another server. So that when you access one point, you will get the whole picture across the regions and clouds. And some of the key features of Graphtino is that first, it provides a single source of truth from the metadata layer because it is hard to move the data. So instead of move the data, we can move the metadata. So to build a single source of truth. And also, we are a multimodal metadata system. So we can support both like tabular data or non-tabular data and others. So we can support like data engineering scenario and AI scenarios to have a data and AI catalog. Also, its architecture, as I mentioned, it is a geo-distributed architecture, and we not just provide the catalog, for example, like the data access or the simple data management. It also provides a unified data governance, like auditing, like access control, and security in one place. So with this Graphtino, we build a unified metadata lake on top of different data systems and trying to unify the data in a single source truth way. So here is a general architecture of the Graphtino. We divided the Graphtino into 4 layers. On the top, it is a function layer. it provides two major categories of functions. First is the unified processing, because our Graphtino provides a unified way to access the metadata, and we also provide the connectors to the different engines like Spark, Flink, Trino, so the engines can fetch the metadata in a unified way and can generate the per plan and execute the queries. And on the right, we also provide a unified governing functionalities like tagging, access control, and others. And this is from the functionality layer. And from the interface layer, we provide a unified REST APIs for different tables and different files and others. And so user, no matter it is a user or engine, they can easily access with a REST API, to manipulate the metadata, the table or file set model topic metadata. And we also, instead of providing a unified REST API, we also provide Iceberg specific APIs because we support Iceberg tables. But Iceberg community also provide a specific REST APIs for Iceberg users. And we think that the Iceberg becomes much more popular, and many companies have the requirement of it to use Iceberg REST catalog. So we also support Iceberg REST APIs. And in the core, our object metadata object model is like a multimodal object model. And on top, we have a meta lake, which is a tenant concept. And for each company or each organization, they will have a meta lake to manage all the metadata under this meta lake. And in this meta lake, we will have the different catalogs, and each catalog will connect to the source to manage the metadata from that source. For example, we have the table catalog, so it can manage the tables from the Hive Metastore or from the Iceberg or from the MySQL. And we use a unified model to manage the tables, and for the users, they don't have to care about whether what the table actually is. We present a unified model and unified way to fetch the table. And we also can manage the unstructured data or the files. We define it as a file set in the as a model. We define a file set so it can manage the files, bunch of files on the S3 or on the object stores. And we also support like manage the topics for the message queues. So if you have the like Kafka or others, you can manage topics. We define an abstract layer and can manage the topics on top of the like message queue. And we are working on building a unified layer to define models. So like Hypeface, and we provide a in-house solution to manage models, unified ways to manage models. And this is the object and model that we are trying to define a unified models. And on the bottom, we define a connection layer because we try to manage the metadata from different sources. So we build a connection layer so it can connect to the different sources like relational database, like Hive Metastore, like Kafka, like others. So you will connect to them and to manage the data on top of them. So this is the general architecture of Graphtino. So let me give you two examples of how to use Graphtino to process the tabular data and non-tabular data. In the left hand is the tabular data. When you want to process the tabular data, you can choose some of the open source engines like Spark, Trino, and Flink with our provided connectors. We have connectors between the engines and the Graphtino itself. And with these connectors, we can manipulate the tabular. We can manipulate the table, like create, load, or alter or drop table. And we provide a unified tabular API, so you can You can create a table, no matter it's a Hive table or MySQL table or Iceberg table. We create a unified way to create the tables and also load tables. When you load the table, the engines will generate the query plan, and so that it can execute. So this is for the tabular data. Sorry. And for the non-tabular data, we also provide a unified way to process the files. And in our Graphtino, we abstract files as a file set, and we provide a virtual file systems. And this virtual file system deal with a virtual name, so users can directly operate on files. That file is a virtual name, so they don't need to care about where the actual data is. And we also provide a unified model for file set, so that you can use our provided like file system, virtual file systems to create, load, alter, or drop files. And you don't have to care about where the actual data is, no matter it's on S3, HDFS, or others. So with this, we can connect to the different like machine learning engines like PyTorch, Ray, TensorFlow, and also like data scientist tools like Arrow, like Pandas, and to process files in a unified way without needing to understand the real location of the data. So here is a usage example. You can use our REST APIs to create a meta lake, create a catalog, table, schema, and a table. And with our provided connectors, and you can use the SQLs. You can use SQL to query the table. For example, we can create a table, and we can use Spark with our provided connectors to query the table, also insert the tables. And this is pretty much exactly the same as you used previously. And instead of just fetch the metadata from different sources, we provide the metadata in a centralized way. So another example is to use Graphtino file set, which is unstructured files. And we can also create a file set, create metadata, data lake, and catalog, and schema, and file set. After we creating a file set, we have a logic concept of the files, and then we can add files on that file set, and also we can process the files under that file set without needing to know the real locations of files. As you can see, we provide a virtual file system, and the path here is virtual, not the real path. So you only need to remember the virtual path and not the real path, and you can manipulate data using Spark, and you can read them as a data frame and do some further processing. Also, you can use like a Pyro, like Pandas, to process them and get the like Pandas data frame and others. So this is file set. So this here is I briefly introduce what the Graphtino it is. So here I will the next things I will give an introduction about the Graphtino usage scenarios, which is our customers currently used scenarios. And the first scenario is to build a metadata lake through Graphtino, because Graphtino can manage the different data sources and manage them in a unified way. Also can connect to the different engines like Spark, Flink, and others. Also, we can provide metadata to like some data orchestration tools and BI tools. So Graphtino on the top can unify all the metadata together and build a unified way. So people, they don't have to deal with each data catalog to create each metadata they want. They can use Graphtino to unify all of them. So this kind of things is try to build a unified metadata lake. That is one typical scenarios our customers currently use. They have the different sources, like they have traditional Hadoop data lake. They have different OLAP systems, and which have multiple tables, and also have relational databases and MySQL queues. And with Graphtino, they manage the metadata on top in a unified way. And the second scenario is using Graphtino to support the federated query scenarios. Because Graphtino can manage the metadata across the clouds, so it knows where the data is across the clouds. And with our provided, our modified Trino connectors, we can support like query, we can support like a cross cloud or cross engine queries. For example, if you have one SQL query, you want to join the data from the two different clouds. And a traditional way is that we fetch the data from the two clouds and serve them and process them in one point. And this will introduce several problems like it is quite time consuming. You have to fetch the data, transfer the data from one cloud to another cloud, and also it is quite expensive. But because Graphtino already knows the location of the data, and also it has the information like cloud information and region information. And with our provided connectors, uh, we can um, analyze the query plans and split the query plans into subqueries and just push the subqueries to where the data actually resides and execute the query and fetch the result back to the systems. So with the Graphtino and our Trino connector, we don't have to fetch all the data. We can do the optimizations. If you want to do the queries across, we will split the queries and doing the operation push down as possible as we can as to save the execution time and save the traffic. And another scenario is like to collaborate data engineering team and AI team to work together. Uh, and previously, every company has like two teams. One is data engineering team. They talk with data, so they talk with table, and their daily work is like to build ETL tools and to manage tables and to generate reports and others. And another team is like a data scientist team. They talk with files and generated by data engineering team. For example, they want to do some investigation or experiment on some data. They will ask the data engineering team to give them to export some tables and give them and to export tables into files and give them a file path, and they will process on the file path and do some further experiment. So this kind of collaboration is connected between the paths, and this path traditionally for the data engineering team, they cannot manage the path because when the data path is delivered to the data scientist team, they lose the tracking. So as a result, they will not know whether the data is still used or not. Is it or open data can be cleaned or not? But Graphtino, it can manage both the table data and the file set and in a centralized way. And they both talk with Graphtino. So Graphtino can manage the lifecycle of the tabular data and file set. And with this, both the data engineering team and data scientist team can talk with Graphtino and use Graphtino provided name identifier to manipulate the table and files, and so that the two teams can collaborate with together. And the data engineering team can also tracking the life cycle or tracking the lineage of the data scientist team. So that will make them to manage data more efficiently and more cost saving. And the final scenario is about using Graphtino to build a generic data agent. Because as I mentioned, like Graphtino is a metadata lake which can manage both the structured and unstructured data and centralize the metadata altogether. And with this metadata and the data information provided at Graphtino, we can build a generic rack system like using Llama index and to build the build index with all the metadata informations. Because traditionally, when we want to build a data agent, we have to collect the data variety of the sources. But now, Gravitino helps you to do that. You can only talk to Gravitino to fetch the information you want and build a vector. And then you can use the vector query engines or the like text to SQL query engines to generate the natural language answers or the text to SQL answers via the AOLM. So we already have a demo about this thing, and we have a blog post, and this joint works with the Llama Index to build a universal data agent in 15 minutes. So it's quite simple. Also, we have a playground to take a try, so you can check out our playground to have a try to build a generic data agent. So this is the typical scenarios for the Gravitino. With our Gravitino unified metadata lake, you can do all the things you want with our metadata lake, and to achieve the single source choose and breaks data silos. And let me talk about the Gravitino community. So our project is open source in the last December, and after the open source, and we attract a lot of contributors and also the users. But we think that we should truly open source it to the community. So we donate our project to the Hodge Foundation in this June, and trying to build a truly open and a large community. And our community is an open community, and we use open technology, and we try to want to build an open standard with metadata, and to truly have a unified catalog to serve for the different purpose. So you can check our project and to have a play, or if you like, you can start. And our roadmap is that we have the where in this year we will have like 5 feature releases and 5 stable releases, and we already have like 0.5 and 0.6, which is the first Apache release. And in this year, we will have like 0.7 and 8 in October and December. And with these releases, we will add more features to support like unstructured data and support like AI scenarios. And within the curtains, we will also release 5 stable releases to make it more mature. And we hope that we can be the first truly open source, open data catalog for the data area, which can serve both the data scenarios and AI scenarios. And yeah, here is the last. You can scan our QR code, check our report, have a try. Thank you.
Questions, comments? Wilson, do we have time for questions? No questions? Oh, you have a question. Okay, let me run for the mic.
Well, one inappropriate question.
Then don't ask.
Well, that's why I'm so hesitant to ask.
Go ahead. Okay.
Yeah, really is compared to the previous presentation, Edge Lake, what are the differences and any overlaps?
Oh, actually, I'm not so familiar with Edge Lake, so the concept seems like quite similar. But we are for the data areas for quite a long time, so we are more focused on data scenarios and AI scenarios. We are not like we are not very familiar with like edge areas. So the stacks or the use the technology that I mentioned, like blockchain and others, we typically don't use that kind of things, and we will more leverage in the data areas. Like, so maybe that's the difference. So I'm not so sure about the like edge lake.
Yeah, I can say a few things. So it's different products, different goals. I mean, you've got existing databases, and correct me if I'm wrong, okay? existing databases, and as an organization, you want to be able to come to one place and know what you got and be able maybe to interact with it. We completely different use case. We're talking about streams of data coming from devices and sources. And what EdgeLake is doing is it provides a virtual database that is created in a completely automated way. So you connect PLCs to nodes at the edge. Those nodes would host the data and create a virtual data lake that now you could issue SQL and get the result from thousands of edge nodes that each one has a piece of data. And the unification is across all the nodes. So it's not that you've got an organizational database that you need to integrate it with another organizational database. EdgeLake is a project that says your starting point is, instead of having streams of bits that are coming from sensors and devices, and you have to figure out what to do there, your starting point is your edge looks like a virtual data. Different use case. Okay. Did I miss something or?
Yeah, I think it's fine. Yeah. Okay. I think it's different scenarios, and also we use different technologies, and the focus area is different.
So is your product like, Informatica and those type of products that do integration?
Sorry.
So the product reminds projects like from companies like Informatica that tries to bridge different sources to unify.
Yes. Yes, there are some similar projects or companies that are doing similar things. And one kind of companies like Informatica or like Antler Alation, they try to build a data catalog which mainly for the governance and for people to use government data and manipulate data. And our product is more like the Databricks REST open source community technology. It is a production. It is a technical catalog. It can connect to end use and then manipulates the data in real time. We don't fetch the data and store them. We just directly operate the tables and operate the data. So it's a kind of different, yeah. The scope is kind of different.
From Malini, from Stanford University. You guys vote? Stanford or Malini?
Stanford first.
Stanford first. Yay, academic first. Go ahead.
Join us for Grog's presentation.
I'm not from Grog, by the way, sorry.
Hey, Wilson. Is it Grog or Stanford? Yeah, so like our AI character has prepared all the scripts, but we need a human intelligence to pick which one's the right order. Yeah.
No, I caused the problem. I had technical difficulties, so mine got bumped.
Yeah. That's okay. We're human beings. Like you tell me 9.11 or 9.8, which one's bigger? You're thinking? Which number is bigger, 9.11 or 9.8? Which number is bigger?
No, it depends if it's a version number or
If it's similar, it's not 12.1.
And the open AI 01 says 9.11 is bigger. No context, that's why.
And the code has been trained maybe on GitHub and all that. And everything
Share the screen?
Yeah, I wasn't able to join the meeting, so I plugged in the
What's up?
USB-C.
He's working on that.
Oh.
Our next presentation will be from Josh Joseph from Stanford University Philarid AI, who will explore how language models can identify the drivers of political polarization.
Okay, sounds like it's working now. Awesome. So, hi everyone, my name is Josh. I'm a student at Stanford University doing research on the intersection of political polarization and machine learning. So my two co-authors were Alice Su, so she's a senior professor in the poli-sci department, and Daniel Hu, from an external organization we do legal tech called FileRead AI. So kind of going a little deeper into who I am, I've been doing ML research at Stanford for the past 3 years now, and I've been working on ML at FileRead. So we've really been focusing, as political polarization has been increasing in this country, on how we can leverage AI tools and products on the cutting edge to kind of create this scalable solution that can reduce political polarization in this country. So going a little deeper, I don't know if you caught the debate a few days ago, but regardless of who you think won the debate, I think a lot of us can agree that political polarization has definitely been on the rise in our country and across the world. And increasingly, it's becoming a bigger and bigger issue as it seeps into a lot of our personal lives and social media, etc. So if you look at the political science literature, one of the biggest contributing factors to political polarization is this thing called political isolation. And you've probably seen this. It's the idea that people who are on the left and on the right are increasingly living different lives, like even in non-political things. Like if you're on the right, you tend to do something completely different, eat different foods, do different things than someone on the left. And the big problem with that comes that you really tend to interact with someone on the other side of the spectrum a lot less. And that's been causing more and more issues in our political climate. So this is just a quick little graph. You can see in '94, the median Democrat and median Republicans' political ideologies were very, very close together. And now they're a lot further apart. So clearly polarization has been on the rise and been a lot bigger issue. So enter our solution, a novel solution called deliberative polling. It was first introduced in about 15 years ago by a man named James Fishkin, and now has kind of expanded to 6 continents across the world. I'm sure we'll hit Antarctica soon, don't worry. But I think our biggest project has been in Mongolia, where they've actually integrated our solution into their system of government. So now to have a constitutional amendment in Mongolia, they use our systems and our solutions to be able to pass that. And it's shown great success. So let me kind of take you through exactly how it works. So we started with the kind of smallest unit of political measurement, which is the poll. So when you think of a poll, what do you think of? Someone gets on a phone and calls you like, hey, do you like Joe Biden? Or hey, do you like this policy or that policy? And you tell them and they report the results in a graph, and that's the end of it. The problem with that approach is that not everyone is an informed voter, and people are informed in very different ways by various different sources. So this deliberative polling process aims to get everybody on the same page. And it's pretty simple to understand. So first we have our pre-survey, and it's just a poll, a random sample of a population, and we poll them on the issues. Then in the deliberation, we have experts come in from all sides of the issue. They debate, they pull out the facts, and they discuss what they think is going to happen. And then we have a recorded group deliberation. This is kind of the secret sauce. This is where everyone discusses with each other, people who have never seen each other before from different walks of life, on what they think of the issues, if their minds have been changed, etc. And then we have a post-poll to see if any issues have moderated. So this actually happened in 2019 in this huge event with hundreds of people called America in One Room. We brought everyone together, and at the end of it, we actually found a very significant decrease in polarization. So we know the solution actually works. It's been proven. It was a very seminal paper in political science. The problem is we have a few challenges with analyzing it. And this is kind of where the AI aspect comes in. It's a huge amount of data, a huge amount of text. We had 20 groups in that event, each of which was deliberating for 6 hours, which means we had over 120 hours of transcripts to analyze. That was actually done by humans. And as you can, yeah, as you can guess, it didn't go very well. Like it took a lot of man hours, and even the accuracy at the end wasn't as high as everyone hoped. And the biggest issue at the end of it all was actually this thing known in political science as the black box of deliberation. So we were able to prove that polarization went down, but nobody knows why. Like what kind of arguments were able to sway people, what moderated people. And it's actually a huge like multi-million-dollar question in politics, as in what are the best arguments to sway the median voter or the independent voter? And that's actually what our solution tackles. So introducing our new model called Delibert. It's kind of deliberate, but with BERT in it. So this is our new model architecture. So we have kind of two components that ensemble with each other, which is the BERT component and the GPT-4 component. So we kind of leverage what's best about both of these models. The BERT component handles the tokenization and classification. Classification being, is this person speaking for ranked choice voting or against ranked choice voting, for example? And then GPT-4 can take that and summarize and interpret it. And there were some problems with this approach that we'll discuss a little later on how we were able to overcome those. But essentially, our training set was based on the US presidential debates with one main key difference. Usually when you train on paragraphs or sentences. But because we were talking about speakers who were speaking from different points of view, which is the same as our deliberations were going to be, we had them trained specifically chunking the text based on the speaker's dialogue. And then also based on the validation set was claims and premises. So based on, is what I'm saying a claim or is it evidence or anecdotal fact to back it up? Essentially, we can go a little deeper. So the results of the training were that we were able to see, this is just an example of the decrease in political polarization. So the table numbers just show the difference between Democrats and Republicans as a median on a scale of 1 to 10. So as you can see, there was meaningful decrease in where they stood. Now let's figure out just some more data about the machine learning model itself. So we basically had humans annotate the same data and our machine learning model annotate that data as well. So it's kind of in the sense a double-blind experiment. And actually, our machine learning model was chosen by external annotators as the top or second best choice 60% of the time, which is actually really impressive because we save a ton of time versus the 120 hours that humans had to work and annotate. Our model runs in minutes. So it was definitely able to make huge strides in the field that's already there. And this is just comparison of F1 scores and argument classification, the accuracy. It's actually kind of surprising that humans were only able to figure out if an argument was for or against correctly 35% of the time. So it's actually good that the machine learning model was able to outperform that and bring higher quality data to political science as well. But this is kind of the meat of the question. This is the main question that we were trying to figure out that I talked about before. What arguments cause polarization to moderate? What can bring people onto the middle ground or to my side, right? That's kind of the million-dollar question that we're trying to figure out. So for that, we had to solve, or at least approach, a bigger question in the field of machine learning, which is claim entailment. How can I figure out where the arguments are and which arguments have the strongest support among all of them? So we did that. Now this is kind of diving into the more technical part using two kind of tools. One is the TOT mapping. That stands for tokenized text to original text. So usually when we tokenize an ML, we start from a set of original text and we convert it into a set of tokens, which is then used by the model and vectorized. And then we had to do that in reverse. And we'll talk about that in a few minutes. But the global attribution tool is honestly the most important thing. Given a claim, like if I say that, hey, median, let's say that, trying to think of a claim now. Ranked choice voting is good, we'll just say that. And then after that, someone asks me why, and I say, here are some reasons why. And then you see how people are reacting to that. That is what our global attribution tool will do. It can go in and highlight the specific tokens in a set of text that will entail or like provide a reason why something is true. And I'll go a little deeper into that to explain. So this is kind of just a normal diagram that shows how Albert, the model, tokenizes normally. So we start from our text and then we go into our tokens. I'm not really gonna explain this very much. Sorry for a non-technical audience. But going a little further, this is the SQUAD model that we trained. SQUAD stands for Stanford Question and Answer Dataset. And this is specifically useful in determining, it's a training set that determines if a claim is entailed or proven by a piece of evidence. And this is useful for if there's a case where the claim is not entailed, like if someone is lying or someone is not really providing good evidence for an argument. So this can actually be able to tell that. So I'll talk about the span labeler model later, but you can see the flow. I'm not sure if you can see my mouse. Yeah, you can see my mouse up there. So you can see the flow that we convert the text into tokens. The span labeler model will then highlight the tokens you can see in this green that answer the question. So the question here is, where is phi used? And we see these 3 tokens are highlighted, and then our map will allow us to bring it back to the original text and say that's phi is used in math. And that's actually a really big thing. So we implemented this using something called the longest common subsequence algorithm, which is a pretty well-known dynamic programming algorithm in data science, but it's NP complete. So it's pretty long and it's overkill. So we're definitely looking for more efficient ones if we can in the future. But essentially the way this works is that it will go through the tokenized text and the original text and find the longest set of common subsequences that it can, which will allow it to establish, as you can see on the bottom with the colors, what tokens actually correspond to the original text. So going forward from that, now we have the ability to, like, we have a set of text and we say, where can I find evidence for ranked choice voting in that text? Then the span labeler model, which I'll discuss in a minute, will return the set of tokens that can do that. And then we can take our mapping and bring that back to the original text itself, which is actually really cool because now I can essentially get an AI model to cite itself. Because if the AI model looks at the text and says, this is my conclusion, we have issues with hallucination and big risks in that. But with our tokenized original text mapping, we can validate if the machine learning model can verbatim cite what it's saying. A little further, I think this slide's a little longer. But this is actually just talking about our span labeler model. So we kind of just got a bit of context from Wikipedia about this tropical storm in 2018 called Tropical Storm Vicente. And the query is, when did the storm occur? So we tokenize it and then we train it. This is kind of the default setting. So we have to see how can we make this better. So kind of going on this, we have a few problems with the way it's going. And that is that most claims in the squad set are not in the form of questions. In the sense, like, if I'm saying things in a normal political conversation, they're usually not questions. They're usually assertions. They're saying that, like, hey, this happened under my economy 4 years ago. Like, I was doing better than your economy. So that's not exactly the nice, clean kind of questions that are going on in the squad data set. And as a result, you get a lot of false positives saying that, yeah, this is entailing this, this is entailing this. You have enough evidence to prove your argument, even if that's not the case. So how do we solve this issue? So we use GPT-4 to generate a synthetic data set, which has a lot more noise in it and even some false or lying claims, which allows our Albert model to get a lot better at detecting untailed text or text that isn't provided, like, proved with evidence. So to do this, I'm not sure how it's kind of small on the screen, but the same way we took our context and we had GPT generate a prompt, such as, where did the storm make landfall? And then we recorded GPT's response to its own prompt, which is correct. So this Mexican state of Michoacan. And then we generated the prompt with attribution. So use a verbatim answer. And then we validated this ourselves to make sure it was right. And based on that, we were able to generate a test set, a training set, and a validation set to train our BERT model on. So going a little further than that, this is our new training procedure. So we have our context, our response, and what in the actual context is implying the response. So from there, you can see we have our training feature and our validation feature, which is actually able to imply that. With this new training, our model got significantly better at being able to get the verbatim citations for a certain claim, which is very useful in politics and in specifically our deliberations, because we can pull out the most strongest for and against arguments for a certain claim. And I'll show you the results later as well. So of course, in order to make our model more practical, we had to add a little synthetic noise. I don't know if you guys have ever used like those meeting transcriber tools before. And if you kind of talk into those, the captions are always a little off. There's always a little noise. People are talking over each other. And our data set was way too clean to handle that. So we put in a bunch of random characters, URLs, synthetic noise, base64 strings that were able to make it a lot more resilient. He knows what I'm talking about, yeah. But a lot more synthetic noise just to make our model definitely more resilient. And it proved true. So I'll get back to this later. I just want to show you guys the results first. So I've been talking about ranked choice voting the whole time. But these 6 arguments here were actually pulled out by our model. So if you guys know what ranked choice voting is, it's the idea that you can actually rank the preferences for your candidates. So if I like candidate A first, candidate B second, and candidate C third, if A doesn't win, then my choice for B will be considered. So it's an interesting proposal, and some states in the US actually already use it. So the strongest 4 arguments is that, hey, you can vote for more than one candidate. and then you can actually don't have to throw away your vote if you're voting for a third party. And the strongest against is that the #1 pick of most people can actually lose the election. And then it kind of elects the least objectionable candidate rather than the one most people actually want. And political scientists agree these are actually very strong arguments for and against ranked choice voting. But our question was, what do people actually respond to? And this was proven to be what people actually responded to as per the exit poll. But rather than having humans look through this for 120 hours, our model was able to find these insights in about 10 minutes total, under like running through 120 hours of deliberations. So having to inference that fast, this solution is actually very scalable to solve political polarization in many, many contexts. And that's why I'm really excited to present this work, because this could actually have a real meaningful and lasting impact, and actually already is. In 6 continents, we're deploying this model and the research to be able to analyze, provide insights for politicians and policymakers on what they should be saying in political ads or what they should be even passing in legislatures that should work. Definitely, if I had more time in the presentation, I could dig a little deeper into that. But just a little thing about challenges in future work. So right now, the current challenges, I mentioned the second one before, is that our TOT mapping algorithm is very, very slow. The longest common subsequence algorithm is famously known as an NP-hard problem, and it takes a very, very long time to run. So trying to figure out another way to establish a TOT mapping would definitely be better. I know that PyTorch and some of the other model frameworks have possible solutions for that, but we tested those and they weren't really accurate enough to be able to be used in this context. As well, we have current challenges. There are longer deliberations. Deliberations in other countries are definitely not even in English, which is another issue. But there are definitely more solutions on the cutting edge that are able to address that. And then just expanding Deliberate's application to other domains. So I've been working at FileRead AI, and we've been using very, very similar technology for the legal context. So we're able to actually provide legal citations so that if a lawyer says, I want to argue X, Y, Z as a storyline, the model will then provide the documents or the precedent cases that will support that argument, which is really cool. I mean, it's definitely a really big value add for lawyers in the legal field. And yeah, so definitely excited to dive into more detail about how this was implemented, how this works, and how we can definitely lower the temperature in our political deliberations in this country. And definitely open to take questions if we have time. Yeah.
In your research with the political polarization and
Use the microphone. Press the button. Press the button.
So in your research about political polarization and political isolation, did you and your team come across a lot about the Russian IRA and their information, their influence operation?
Yeah, so that actually didn't come up that much in this research, but we're doing a bunch of other research in the Deliberative Democracy Lab that's specifically involved. I mean, I don't want to say it here, but like we did delve a lot into TikTok, and as well as a lot of other social media platforms where there have been like lots of good information and lots of correct like dissemination about registering to vote and everything, but there's definitely been misinformation as well, and how that's like we've had repeated claims that our deliberations come up again and again that have definitely been false. But we've been able to pick up on patterns that have emerged. Like this argument seems to be brought up a lot, even though it's been like patently proved false. And that's probably where a lot of this polarization decrease is coming from. People that have been given misinformation, but now see that like, hey, some of this might be factually false. There might be a grain of truth here. Like, how can we more appropriately reach a common ground? But yeah, there's definitely an application.
Yeah, exactly. Because I think one of the things that are very successful at, and which is I think is kind of interesting, is that they didn't necessarily take a side. They really just spurred the polarization. They didn't care about which side they stood on.
Yeah. I mean, I don't want to get too much into that, but there is definitely an incentive there for them to kind of drive people apart. But we're trying to help do the opposite, so it's a good sign. I think hand there.
Yeah, so well, I want to understand, what is the goal for this project? Is to help the pool more accurate, or it's to kind of help the politician to deliver their messages more accurate?
Yeah. So the original goal of this project was to accelerate the speed of deliberative polling. So originally, as I mentioned, like deliberative polling is this process that has been proven to reduce polarization, but it takes a very, very long time to analyze and complete. So that's the original goal of this project. I was kind of just talking about possible applications that could go on this, because like in a nutshell, what our project does is it's able to pull out what are the strongest arguments for and against a certain proposal that actually sway people's minds. Now that idea in itself has so many applications, even in terms of like social media. If I want someone to buy something, what are the arguments for buying this product? Or in politics, like what are the arguments for electing me as a politician? So yeah, like as you mentioned, there are so many different applications, and this could expand into that space.
Also, a technical question. How about now the context window is become longer and longer? How about just feed the whole thing to the LLM and related to all this kind of tokenization and other stuff?
Yeah. So we have been doing that, especially if I go back to the slide where dealing with longer deliberations. So increasing context window size has definitely been able to help us have longer deliberations. The thing is, even with those longer context windows, the size of the deliberations are just so long. Like as I mentioned, each group was going for around 6 hours of talking back and forth. So at least at this point, I don't think there are any models that will be able to handle something that size and still maintain a recall rate that's high enough for pulling the strongest argument. But definitely as it improves, that's a good research direction to go in.
Last question. What's the normal size of the group?
Normal size of the group, I don't know if did I write that in here? I don't think it's in here, but I mean, I actually participated in one of the deliberative polls to get a feel for it. Normal size of the group was around 15 people in each group.
50, 50.
1 5.
Sorry.
Yeah. So that's like small enough to allow you to have a good conversation with somebody and get to know them. Yeah.
Hi, thank you. Can you clarify how knowing the for or against argument, how will it help me soften my views? It could help harden views as well, right?
Yeah, for sure. We've just found in our research that it typically helps soften views, essentially because what a lot of kind of more biased political sources tend to put up a straw man argument or a red herring that doesn't really address the core of like why a certain side could be a little less extreme on the issue. That just happens to be what the American landscape is now. But like, for example, if most voters were like in the center, if it was a curve like this instead of 2 curves, I'm sure like doing a poll like this could actually like make people more extreme. I just think right now that our country is extremely polarized, that this is a net positive in pulling people together. Yeah, there's definitely an argument to be had. Even like is pulling people to the center even a good thing? Because maybe something on the edge is the correct answer. So.
Thank you, Josh. Let's assume other than polling, you can take like written descriptions or speeches or some other forms of input. In today's election, did you try anything along the lines of like abortion? What would be a way to soften people to accept it or propose it to make both sides come together?
Yeah. So there are actually like so many more issues. I was just talking about ranked choice voting because that's the issue that our deliberative poll was focusing on. But there are so many more. Like if you go to like ddl.stanford.edu or something, I think that's the link. If you just look at deliberative democracy lab on Google, there are at least like 10 to 15 deliberative polls going on across the world right now. So this research is being applied. I'm not in charge of the research that's going on there, though. So I don't think I can speak to it.
Curious if you had checked them.
Yeah, it's definitely happening. These things take a bit of time, so as it goes, it can go a lot further. I think Jeff's had his hand up for a while.
I'm trying. Have you thought about, in addition to strongest argument that you mentioned as when you summarized your project in a nutshell, have you also thought about credibility of the scores? Like I've been imagined for a long time that there'd be a website called like say trackrecord.com. And it would be a filter. So anytime I'm reading an article, I pull up a Bloomberg columnist or something, it first goes through this trackrecord.com and he tells me how many times this guy has been right and how many times he's been wrong in like say the last 5 years. And he's been wrong 90% of the time. Okay, forget that. He must be biased or he's got an agenda. I said, I'm not gonna read that. If you could somehow in addition to pulling out the arguments, it's way also figure out who is credible over time. I think that would also serve to, that might be something that convinces people to pay more attention or say, I might change my mind, based on this, whatever this person is saying.
Yeah, I actually see that application in being, there's a lot of people that only listen to a certain side of the political spectrum or only even a certain set of media personalities. So that kind of like track credibility website could be good in introducing someone to someone they might necessarily even listen to in the.
Yeah, or like a filter. Like if you want to get the news nowadays, you got to go read half a dozen sites.
Right.
You got to read far left, far right, somewhere in the middle. And eventually you might say, okay, well, here's a consensus. That takes a lot of time. I keep thinking a large language model, it could do that.
Yeah.
But nobody's done it yet.
Yeah, that's actually a pretty good application of this. I mean, I'll probably talk to someone about it.
Sorry, one more question. Okay, so you mentioned there are certain states that are doing this running voting. Can you tell us what states and what level are they doing it at?
Yeah. So I think right now, because of the way federal election rules work, like they can't do it in presidential elections. However, I know for a fact the state of Maine has run it in state elections and even like elections for U.S. Senate and governor, etc. for a while. I think there have been a few other ones too, but just off the top of my head, I know Maine's been doing it.
So if I understand correctly, the input for your algorithm is the transcript of this deliberation session.
Yes.
Which kind of.
So the input is the transcript of the deliberation session, which captures the text, but not things like the tone of voice or the facial expression or stuff like that. So do you plan at some point to do maybe a multi-model input that will include things like that, like the tone of voice or any other parameters? Because just judging by the text, it's not always reflecting how things were said, or maybe they were created more reactions because they were said in a certain tone of voice or level of voice or so on and so forth. So did you give any thought to that aspect?
Yeah. Actually, there's a whole other team in our lab that's working on multimodal applications. Especially in political science, there's a measurement called affective polarization, which is really based on like not how I feel about how the other side's policies are. How do I feel about the other side as people? And unfortunately, that's like also been trending in the wrong direction as well. So like there's a whole area of our lab that's focusing on affective polarization, and that's really focused on like what are the like emotions of people. There's a kind of ML semantic analysis, facial facial kind of like emotional identification, like what is your tone, what are your reactions to someone's right after they say something. That they're kind of focusing more on that. I mean, I'd definitely be able to talk to you a lot more on that later. Yeah. Other questions? Sounds good. Thank you.
You can wait for another talk from Malini, or we rather have Malini talk at the opening of this afternoon. It's 10 minutes. Or yeah.
So what's the question?
Because we want to have a group photo. We don't want to miss you.
Oh, yeah.
Either take group photo right now.
Oh, yeah.
Then you are good to go.
Yeah, that was great.
Yeah, and then Malini can have it opening for the afternoon. Yeah. How about that? Yeah, everybody, we call Gary, where's the better spot for group photo? At the front? Yeah, enough space? Okay, everybody come to the front. We take group photo and then we can have.
Maybe you can put the slide of AI 4D.
Oh, yeah, sure. Do we have the slide now? For these slides? My slides.
Good thinking.
Yeah. Oh, hold on.
Yeah, hold on.
Hold on.
We still have growth, need to have presentation.
We have the graph.
Yeah.
Oh, yeah, okay. So, can we have photo first, then he can leave, then we have, you are gonna miss the graph. That's what you want, right? Okay, yeah. Because Dr. Du is the ex board chair for ELF AI. and this is a joint.
Oh,
See,
previously.
we
this
all
year
do
I
it for
was-
you, okay? Let's do it for you, then we have a
Yeah,
graph
yeah, so
presentation.
thank you so much. We can take a photo first and then we do this.
Yeah, then we have a graph,
Yeah,
yeah.
we have amazing like presentation from the, we're
Yeah, yeah,
excited about this.
Okay, yeah, just like exercises. Everybody come, please, move to the front, take photo.
It's up to you. Yeah, but this is pretty tasty, right? Vegetable.
Yeah, let me stand there as an anchor. Okay, come to me, come towards me.
Josh.
Thank
you.
Yeah, I'm sure. The 6 feet, the last row.
Definitely answered.
Generic,
Take a group photo right now. I'll tell you in like 10
We
seconds.
can't hide you in like the STEM students. We are alumni.
Okay, guys, can sit in the middle.
Hey, we need somebody else. We need you in the picture. Yes.
It's fine, it's fine. I can take photos.
Undergrad.
The third one?
Second year.
Second year.
Yeah.
Oh my God, so
Great,
brilliant.
she's still talking about.
Wilson,
She has kids in grades.
I'm in 14th grade.
14th grade, that's great. You did that young.
Getting closer.
Yes, that's
Okay, it's fine.
You know, your classes.
Okay, guys, 3, 2, 1, smile. Amazing. Okay, one more. 1, 2, 3. Perfect. Oh, okay.
Exchange, okay. Yeah, our
Maybe
amazing
Photoshop
team and like Gary and Wilson, they.
I really haven't seen
They
it.
is together, yeah.
Very helpful. Everyone say cheese.
Cheese.
Okay.
Okay, guys. So that's why it's the short presentation.
Now we have the broader presentation.
Oh, it's okay. Yeah.
Like this is the last presentation.
It's on the
Really?
Okay, before presentation. You guys want to do lunch before?
It's fine. It's up to you. What do you think?
Can you see that? Yeah.
Yeah, we have a lunch first. For secondary degree, and he will present after lunch. Are we not
Can you say
ready?
something about lunch?
Us ready?
Join us for Grog's presentation.
Sandwiches.
Okay, let's have lunch first.
Is lunch ready?
I don't want to stand between.
I don't know. You.
Is lunch ready? Yes.
Yes, it is.
Let's have lunch
Okay, but
first.
let me say something. Wait, everyone, listen. If you want the graphs, the labeling is on there.
We have a lunch first, then we have the graph as the first presentation of
The
the
graphs
afternoon.
themselves are not labeled.
So does it?
What is it?
Lunch now. We have.
That one.
No, actually not. Even there.
Oh.
I don't know. It says Southwest Chicken with.
So there's
Veggie, hummus.
Taylor Swift. Taylor Swift. Whoever you love. We are different tastes. Let's be careful. Lunchtime now.
No, they have.
Yeah, we have made lunch because Jose. Really sorry.
I'm from Texas, so it's particularly.
You can actually notice.
First. This part.
Yeah.
This part here.
I think the best thing is if you live in this part of the area.
Everywhere you go, that's their reverse way of making you.
Yeah.
That's the location.
Oh, it was fun.
Yeah.
I ran into school.
Oh, yeah, it's very good.
I think these are the last night.
Yeah, no, they.
Not so much into. Cheerleading, kind of like drag people like get out of that chair. Yeah. Or leading.
That's like a first rule of
Doing good. Here, asking. They were asking questions by the project. Right now,
That's good.
So what?
Nobody realized it.
No animals were harmed. Yeah.
I wanted to ask that question. Just you're clear that we're trying to use prep. Set up.
Oh, how do you know what these are?
Startup in AI.
Japan is that. What is the US? But the US and also some little press. In such case, but the 5G that how related. That spikes up usage.
Now for the new company.
So why do you need BD? What kind of BD?
I was hoping. That's okay.
Is it on the AWS?
Or the public area, so.
You know what's
business 都不了这么久，而且他还要 apply 好。
知道你怎么答这个，然后下面有个
No, are you? Any kind of it's a good fashion. I think a lot of basically, so the reason why
I'm really trying to understand how tokenization, not any gets one.
So we're sort of like, yeah, we registered the name. It's not like I think
You managed to get change his mind. You should see my picture. I look way over. I'm just LinkedIn. You wanna?
Yeah, no, they cannot.
You're good. I know you look much younger now. Good job.
It's not like
your startup sounds very interesting.
So let me explain to you what it is. I mean,
Oh, you should see mine. You wouldn't even recognize it.
yeah, basically, use it for inference.
Like space. Yeah.
Well, basically, it's a that have like they have parents which means have whatever.
Yeah, that was hell of a scare.
That guy, lighted guy.
And with social, like.
He did the lighting.
That's a lot of
Yeah. Yeah. They sold fuel for somebody. They sold things like that.
Oh, no more, right? They're no more.
But I wonder about
They're still there. They're right next to my office.
Now it's like.
Those are the best customers.
So everything's so fast for
Oh, okay.
like you're starting there or doing some research? I work in analytics industry. There's a company called Day2. I do products and a lot of enterprises. AI analytics and all. So say for our customers, Meta, eBay, building advanced analytics. And I manage high-tech. So I manage and some of our relationships are like last 10 years, 15 years.
Yeah, of course.
And we are a small company. We've been public for a year last year.
So we would have to have.
We don't know. Yeah. So it's been really
Yeah.
What were you doing?
So I was in food
To go back to startup world.
personality disorder. I don't know.
I'm here. Say for example, you want to buy the Apple comes in for something like you already have a large customer base. Someone very small have to be highly innovative, and then to innovate for all small companies.
That's why a lot of the So I don't know. I think it's probably leaning more towards something very
We as the right company and make decision.
I still have some daughters.
At the same time, maybe absorb and you can make the like. See, once you or like only AI related.
The driver is the one who's
so my
some students from
So this is.
I like to see my recipes. Yes. Okay. The robotic arm. It's hardcore. It's high code. More motions. Hey, we are on the same fashion. You open up education,
Yeah.
Welcome for the high code. Like my thing the number one. Well,
5 years back, not with the help of others. Running and brute force. Now the compute coming and technology coming, we are like adopting it very fast.
Lights on the field.
I would rather go Floyd talking to Jan
Yeah, and I might have stayed longer, but back then in China, they're cold. And again,
Give me all your data. And you know, what you're learning. Yeah. It's like you don't know.
Yeah, yours?
I heard about it, but I thought it's.
Somebody acquired.
Oh, yeah. I worked there.
Yeah, that's the point, bro. No, it's fine.
So I don't know if you saw that. So he transformed this. He transformed the edge to a virtual data lake. So you plug our software where you can see generated. And then when you look at your edge, you can see it in the virtual database
Because I did read
Don't count on the edge device. So I showed the use case. It's a smart city. So smart city has generators. They generate electricity. They have water plants. They have a wastewater plant. Data goes from the data comes from the field. Some edge nodes that are, I think they use the node.
Oh, got it. So you need edge computing like an
Instead of the data to the cloud, it stays there. When you look at your edge, you see a virtual.
That's very fast.
Don't need to figure So for example, in this city, before we came, they were involved in a 2 year and they didn't finish, and they deployed us within days.
I can promise you.
Go into Costco. Yeah, it's hard. They say every day you delay the probability of testing. Yeah, they assign me. I'm a pretty good I will look up your presentation.
To be smart city, work with machine learners, there were some errors.
I know so many other
I was oh, very nice kitchen.
Sorry, I missed the first part of your presentation.
Yeah, but for your question, guys, yeah, I actually started.
No, I'm familiar with data, but when you talk about security and how certain data can that was more my question, not the lack of understanding. I actually, my background is I used to work for SAP, so my background is data integration. Familiar with it. But you have to start up, which is a news startup. It's a slightly different spin on news. Like a lot of times you it's like 5 years ago, 2 days ago. Real like there's other companies that do stuff like this, but other companies try to figure out what you want to do. Kind of say, well, you know what you want to know going on. You want to know how it's being reported. Stories from one or two organizations. Pointed out, actually, we were trying.
Ladies and gentlemen, eventually we sit down and Jose from Prague is gonna give the speech. Okay. If you see people outside and around, call them in. We go in person to get them in.
Oh, really? I'd love to.
I mean, it's not as nice as well.
Okay, if you want to do an event, you want your friend, just not here.
That's what I would say.
I predict 3 years. תשמע, אני רוצה למצוא איזושהי דרך לנצל אתכם, כי למעשה, עכשיו גייסתי כסף מדחב, עד עכשיו שמענו את הכל בלואו פרופייל כזה, היו מהנטוורק שלנו, אף אחד לא מכיר אותנו. אבל הכל הולך להיות פלטפורם על האדג' אין היגיון. זה הדבר המשמעותי ביותר, במקום להסתכל על סטרימס של דאטה, להסתכל על תמסרות. דרך אגב, אנחנו מדברים גם עכשיו עם 3-4 טלקום.
טלקוס, כל הסיפור הזה אומר שבעצם להיות דאטה סרוויס פרוביידר, במקום רק לזרוק את הדאטה לקלאוד. דאטה סרוויס פרוביידר, נקרא לזה מולטי ביליון דולר אופורטוניטי. כל אחוז של דאטה שנשארים באדג' והם יכולים להגיש את האפליקציה. סיפור ענק הבעיה הזאת, אוקיי, אז פתרנו את הבעיה הזאת.
רגע שאתה אומר לי לא יודע, עושים את זה, זה לא זה לא הבעיה
אני לא רואה את הדאטה שלי, בוא תפתור לי את הבעיה, אין לו שם, אבל זה מה למעשה משהו מיוחד. אנחנו לא אומרים לטלקו אנחנו אומרים, אתה תיתן את האקטיביטי, הלקוח מוריד את הנילוק, תשמע, עשיתי את זה, מה הפשוטה הזו מה שלא, עכשיו יורחים לדאטה, אין שם, זה לא סוג כמה קליקים. כאילו יש שם SI, אבל בגדול, גם ה-SI זה לא בנוי להחליף את המזון. תקין את זה, הוא רואה את דאטה בייס, עכשיו הוא עובד מול הדאטה. נכון, הוא יודע צריך להגיד. זהו, הוא לא יודע איך זה עובד. הוא לא יודע, הכל נפתר בצורה מאוד. יש כאן, אני מסכים למה שאני אומר. מה שאני אומר, יש כאן איזה משהו שהוא פילינג ללמוד, זה נכון שקשה להעביר בכלל ללמוד, אם בכלל מתאים אותם נכון, אבל יש כאן שני דברים שהם לא היו, לכן יש טכנולוגיה שיכולה לעשות. זה שלא נופל על הטלפון, אף אחד לא יתקשר אליהם בצורה שבה אני אומר לעבוד ויגיד, היי, היו לי, אני לא רוצה לעשות כלום, כאילו, זה לא יקרה. הם מורידים, הם שמים, הם חזרים אני רוצה להתחבר אליו.
Ready? No, no, for example, type C started, so I don't know why did someone change the permission.
Join us for Grog's presentation.
You're right. It's not working, so they just say use your laptop.
It is recognizing, yeah. There you go.
Oh, yeah.
Wait for our AI character to say something. Wait for the AI character to say something. The AI character?
Already done.
Done? Oh,
Yeah.
oh, sorry, when? Before lunch?
No, it's
That's
just.
not, oh, I missed it. Okay, your turn. Sorry about that.
There we go. All right, hi everyone. My name is Jose. I'm an engineer in the cloud team at Grok. And can I see hands? Who's familiar with Grok here? Okay. People. I'm very glad I'm getting to introduce it to a few of you. Grok basically builds the world's fastest real-time AI inference. Okay. What does this mean? Inference, there's two big times on AI. There's training and there's inference. When you talk to a model, or when you, for example, when you talk with something like ChatGPT, you are doing inference. And that's what we do. We are not concentrated on the training part. We are concentrated on the inference part. I forgot some mic. Okay. We all know GPUs are related to the whole AI thing. Do we know why we use GPUs instead of regular CPUs? Because GPUs are faster, up to 100 times faster on AI operations, right? And they are, by the way, very good at training, but we designed a chip that's specifically better at inference. And you can clearly see there's like the specialization part of the chip, it's like visibly different. So one of the things I like. This is a comparison between providers that use GPUs for inference. And the line on the top is the Grok's performance. In this specific case, we're talking about, I think it was level 3. And you can notice how the chart is not mine, is from the folks from artificial analysis. And they have to stretch the y-axis to fit the performance of Grok. We have reached, I don't know if this is updated, but we are north of 400K developers as of today, registered on the platform. You can go try it right now. It's actually free. Why is it free? Besides us believing in the mission of free compute for everyone, the service is rate limited. Okay, if you want a paid tier is coming later, but you can go to the console today and start trying. And from here, what I'm going to show you is just cool demos. Now, oh no, this is not a demo. Sorry, just want to give you one quick good example of why inference speed could matter, and this is called mixture of agents. Picture this: when you take a photo with your phone's camera, in most modern phones, the phone's not actually taking one picture, right? The phone is taking many pictures and it's stitching together what it thinks it's the best parts of all these different pictures. Mixture of agents, this is not mixture of agents, but it works similarly. Good example of this is if you ask ChatGPT, for example, it depends on what version you're using, you have something like,
give me, the typical demo we do with this is give me 30 sentences that end with the word apple. Okay? A regular model is gonna screw one of the lines at least. And if you do this technique where you do the prompt, you have different models, you combine the question and then you iterate on this a few times, you can get a higher quality answer, right? So it's similar to the phone example I was giving you on the pictures in the way that you can iterate on the answer over and over again, and you get to a high quality result. We have a demo for that as well. And I really recommend you guys digging up on that one. By the way, I'm gonna have QR codes at the end of the presentation for links and stuff, so don't worry. Now, this is a demo I love that it's called Infinite Bookshelf. Basically, you can enter a topic on which you would like to learn and just starts going, right? You can start learning about the topic, the shape of the book, and it's happening because it just keeps going, right? Next demo. I hope I didn't mess this one. This is a demo. I didn't make it line. This is a demo called Draw and Guess. I'm gonna open the link. This is a replay you can clone. I'm gonna access the link here. So this is a vision demo, which is image to text. Okay, what does it mean? That I'm gonna draw something. In this particular game, we're trying to make the machine guess. We are gonna draw something, and the machine is gonna learn. It's gonna learn. It's gonna guess. So if I say, "What's this?" Set star, and you can see here that it took 0.042 milliseconds to guess what the drawing was. And you could be doing the same with slowly drawing circles and see how the inference just gets better. And we go from smiley face to Halloween really quick, right? So this is a very simple demo. The prompt is extremely simple. Just I'm asking, answering one word what you're looking at, and it just took 0.07 milliseconds to do the last inference there.
How many output tokens? Can it say pumpkin that's carved?
Yeah, for sure. So I think I disconnected this. The prompt is very simple. I'm saying describe the drawing you're looking at. I can go there to the code and see, and I give a few examples of I wanted to describe it in one word, because sometimes you say please describe in one word and uses a full sentence. But it's right there in the demo. Sorry. Specifically, I'm pretty sure it is use. Oh, I remember now. This is the prompt. Describe the image in one word, please. And then you have a few examples of how one word would look like. That's how I got to the model to use one word. Now, right here I'm using, as I was saying, image to text. The specific model is Lava, and Lava is trained on top of Llama 3, I believe, and it's really good at using saying things like you can take a picture of a product and can describe the product. So there's a certain providers that are using for e-commerce. You can see how that would be very convenient. We introduced Whisper a few weeks ago. Whisper is transcription, which means you can enter an audio and it does transcription. It does the transcription up to 200x faster than other providers. It's really, really cool to see that at work. Yeah.
So Infinity Edge AI already used the Whisper. We have the open source code, and if you have that.
Yeah.
We were looking for the best hardware. We tried CPU and GPU. Next one we're gonna try is LPU.
You should definitely try the GPU. I think it's actually let me show you the QR codes before it dies. These QR codes are developer console, Drongus, Stockbot, and Stockbot. I didn't show you Stockbot. It's a demo of a robot that can give you information on stuff.
The power outlet just under the small table. You can plug it under the small table. Under it.
Oh, thank you. Yeah, but I'm using that one. And that's pretty much it. You guys have any questions? This is really shoot. That's a very common question. Of course, you can get in touch with the sales team or with, can you definitely can. We already have customers, paying customers. We're just onboarding them little by little. But I encourage you to go to the get in touch with the team using the Discord and explaining your use case, and they can you gonna like that.
I feel like it works. It didn't work earlier.
It worked?
Yeah, it works now.
Perfect.
Do you know if you're gonna bring back the 405 Meta 405 building?
405, yeah, it's on the works. Right now for us, the name of the game is capacity. We're building the chips as best as we can. And we did have 405 for a while when we launched when it was released, but the demand is the demand is an interesting game. So right now we're, but it's coming for sure. It's coming, and along with more surprises.
Do you have like contact to for like the dev team in particular? Because I have some like things to address them about like the website itself.
Can you repeat the question?
Do you have like contact with like the the development team, like maybe more specifically like the front end team? Because I like see something.
Sure.
And I want to address
them. Definitely talking to the right person. Okay.
Right here.
Okay. Any more questions? No, thank you very much.
Okay.
One more guy.
Yeah, Holiday was supposed to give an opening this morning, but there was some technical IT issue. And she finally drove here. Now she's giving a due opening for the afternoon.
Hi everyone. So instead of opening, I'm doing continuing. So welcome back after lunch, and my talk is really short, but I'm here to tell you about a new project under LF AI and data. It's called Open Platform for Enterprise AI, OPIA. And I'm Mani Bandaru with Intel, and I'm the OPIA TSC chair. And with that, let's get started. So I really shortened this slide set. This is 10. And everybody here knows about RAG. Everybody knows about the AI challenges. So we can go through those. So the agenda is Gen AI adoption challenges, a closer look at OPIA, and how you could get involved. So all of you know this RAG pipeline, assume, presume, etc. So there's a lot of data processing. There's chunking it, embedding it, retrieving things after you put them in a vector database, and then of course afterwards combining everything and going into a LLM or a VLLM or whatever to make some statements over there. Whether it's recognizing stars or pumpkins or telling people what and how they should vote. But that said, that's what the AI part is. But what else do we need? If you want an enterprise application, you just can't ignore things like security. And if there's data in a database, is somebody like Mani allowed access to it? So you still need all the things like authentication, access control, scalability. You don't want to have more LLM instances than you absolutely need to because they're expensive and they cost a lot of money. And you need reliability. If one keels over, another one should pop up quickly and take space. And you want to do all this at low cost. So that's the enterprise angle. So the name OPIA, Open Platform for Enterprise AI, has both parts, the AI and the enterprise, and it's all open. So if you were to look at Gartner's report, their top challenges for Gen AI adoption in industry is that it's technically complex. This room is full of smart engineers, and that's a very different environment outside. There's the cost angle for training, even for inference, and then there's a talent scarcity. And of course, there's no talent scarcity in this room. And how do you typically handle things like this? It's about using open source. It's about having open ecosystems, and that's what we're trying to solve over here with OPIA. So the OPIA vision, we kind of hammered this out a few weeks back, is to enable enterprises to develop and deploy Gen AI solutions powered by an open ecosystem that delivers on security, safety, scalability, cost efficiency, and agility. Okay, so want it open, and where does it live, therefore? And Tina knows best too. She's been in this edge space and LF edge, and that's exactly where OPIA lands too. It lands in the LF AI and Data Foundation, which provides us all the open governance, all the open source best practices, things like how you hold meetings, who gets to vote, etc., etc. And what else? It's supposed to be vendor neutral, so invite any and every solution that does make sense for these RAG pipelines, use open models, allow people to do whatever they want with these models and their pipelines. So you don't want to be the big brother over there, but you still need big brothers around. And all of this is going to be cloud native. That's the thing. Everything goes in the cloud somewhere at scale, whether it's at the edge or in a data center or anywhere, so cloud native. But what else does OPIA want to do? It wants to do tested performance, scalability, safety, bias, all those kind of tests, so evaluation along all those dimensions, and provide efficient reference implementations. So I come from Intel, right? And we're all about performance and before our current sad state. These were a company that made fast machines, awesome machines, and it was all about like, hey, I can do a little better on spec JVP or spec int or whatever. So it is about performance, but it's also about performance on different hardware. So OPIA will host CI/CD pipelines for all the hardware vendors. I mean, they bring their own hardware, of course. And then we do performance across these and then see what works, what doesn't work, and what's going to be green for you. So a little bit more about its governance, because it's open. I have links here for whoever has the slides later, where the OPIA home is. where there's a calendar for you to sign up for work groups, how to join the TSC meetings and, shape this future of ours. We have currently 9 TSC members, and our most recent addition is from AMD. So it's really now open, not just Intel hardware, Intel CPUs and its accelerators, but we also have AMD joining us. And others are welcome too. And our TSC represents like end users. So we have Comcast and Fidelity. They want to use AI inside their portfolio management and things like that. Comcast for telling you what movie you should watch or what other plan you should adopt. We also have system integrators, and as I mentioned, hardware vendors. And then we have enterprise deployment solutions like Red Hat, etc. So please do take a look. Please do consider joining, because AI is ours to harness, to ensure its safety, to ensure its openness, etc. So with that, let's just take a little closer look at what's inside OPIA. It's organized as follows. We have a bunch of components that's up here. These are things like your vector databases, your large language models, so on and so forth, re-rankers, guardrails, anything like that. And the difference, as I said, coming from a company that does performance, this time around wasn't saying, hey, do quantization, you'll get this much and that much and things like that. We said, let's start with the pain points of industry. We have all this awesome LLMs and VLLMs and people making images, but what do companies really need? We have too many documents. Can we process them faster? Can we summarize them? Can we look at bulk databases and say, hey, what you're looking at right now looks like XYZ. Maybe the solution is along the lines of how you solved it before. So just, like low-hanging fruit that solves real-world problems and makes our life a little better. So we improve our productivity. So the Gen AI examples pretty much capture such, necessary pipelines, Gen AI pipelines. And you saw a whole lot of them on day one with, the fashion industry and developing apps for them. So this is along those lines, but it's a chatbot with audio, video, whatever input you want, document summarization, code translation, code generation, so on and so forth. And then the Gen Eval sub-project under OPI is all about evaluating it, not just for performance, but things like safety, toxicity, sentiment, and things like Josh talked about. And then the Gen AI infra is all about connecting these in an enterprise environment. So what do we need in the enterprise? Like authentication, authorization, scalability, reliability, and we leverage all of the goodness that comes from Kubernetes. And then other open source projects like Istio and Envoy, and then service meshes, and also patterns like operators, drivers, etc. in Kubernetes. Okay. We have one other thing in the Gen AI infra that we call the Gen AI microservices connector, and that's it's like a macro if you were writing C. So how you can write these pipelines and have special operations there, like switching, parallel operations, and even things like just plain old sequence, do A, B, C, but maybe for A, you want A1, A2, A3, because you want to consult multiple models. So dynamically, when you can switch out the models you're using. So with that, how do you get involved? So we have a hackathon coming up. It's a whole month long. We invite people to come and try what we have there. Of course, it's not going to be perfect. So please throw in issues, bugs, whatever. And of course, bring your creative juices, bring in new examples, maybe even bring in new languages. That's something that Josh mentioned too, that we have on the English sentiment analysis. Why not Mandarin? Why not Hindi? And so on and so forth. And what else? We have one end of the month event, because it's Halloween theme, like that pumpkin. So any nightmares that you'll have encountered with AI and how you address them. So with that, thank you. Go ahead.
Quick questions?
Yeah. I'll be the fall
So I have a couple of questions. So you mentioned data. So you have data within OPE framework? Like what is
the data will come from other data commons. So you can bring your own private data if you want to load into your vector database, whether it's your proprietary bulk database, whatever. but it's mainly the open source models, the open source tools like vector databases, etc., etc. But the data will be maybe proprietary or from some data commons.
Okay. And how does it relate to, say, Hugging Face, for example, other open source projects?
So Hugging Face is actually hosting for you those models. You can use those models here. So we don't make any claims about the models. You can use your Hugging Face token and just bring it here, or you can use an Intel model or any other model.
So why would we bring a Hugging Face model into OPA? What would be
so the main value is it does the whole pipeline for you. It gives you like template reference pipelines because it's not just the model, right? A RAG application has the data pre-processing. Then you choose whichever vector database you want, and then maybe your guardrails. So it's that whole end-to-end solution that OPA is trying to make easy, cookie cutter like.
Oh, okay. Okay. So it's kind of an integration.
And using cloud native best practices underneath to deliver it. So whatever you have in OPA, you can run on-prem. You can run it in your favorite cloud provider, or maybe even on your laptop if you're a developer. So just in that scenario, use a smaller model.
Okay. And the third question, I don't know if others would care about it, but I'm asking it because I come from Intel and I know Intel has a huge developer cloud.
Yes, yes, yes.
I'm curious why you are not using Intel Developer Cloud.
Oh, we're using it.
You are using it.
Yes, yes.
Okay.
So all our CI/CD is running on the Intel Developer Cloud.
Okay.
And pretty much that's the only place we have Intel Gaudi tools, and we have a few Intel Gaudi tools in Amazon Cloud. So we are definitely using Intel Developer Cloud. It's a baby cloud right now, so hopefully as it matures, we could even offer it as a cloud service.
But Intel Developer Cloud is offered to developers. I have offered it to developers outside of
Yeah,
India.
yeah, but like
Yeah, I mean, it's not like a
customers type of
commercial.
thing.
Yeah, it's not for paying
No, no, that's the aspiration to make it
Oh,
paying.
oh,
Yes,
oh,
yes,
really?
yeah.
Okay, I did not know that.
That's why I call it baby cloud.
Got it, got it. I have another question also, but I'll leave it for other audience and
Anyone? Maybe you're my only friendly audience. Please ask. Maybe I paid her to ask the questions.
So there's another, like, in my talk, and I don't know how many people were there yesterday. There was a question raised. I don't know if you've heard of the challenge that Sam Altman referred to when he went to in India. Like somebody asked him the question that if you had $10 million and 10 developers, can they do what OpenAI did? And the question was like, question that was posed to me was, most other AI training models, they need like, a lot of resources and they won't be as fast. And that's the reason why it cannot be done. So is there something along the lines of that in OPA or anything that can be created like to find alternate of running AI, which is not that resource hungry?
You can always have non-resource hungry things with smaller models, and I think it's our moral obligation to do research in that space. We shouldn't aim for huge models that just make a big fat carbon footprint. So I do want that to happen. But with just 10 developers and $10 billion, I don't think we can do anything. Because what's the whole reason we have open source? It's to bring everyone together. You need the minds, the diversity, the passion, the time. I mean, you need all those. We still need everybody to come and join forces. Linux wouldn't be what it is today if it hadn't been open, and that's
Yep. Okay. Of the audience.
Hi, I'm Rani Haiband, CTO of Networking and Edge of Linux Foundation. So first of all, I'm excited to see another project emerge under the Linux Foundation. Great work to you and the rest of the community. One thing I often observe with kind of these infrastructure projects like Opia is that if you try to be very generic and address all the use cases in the world, you become kind of a jack of all trades, master of none, and you're not doing a good job. But on the other hand, if you focus on 2 or 3 use cases just as a starting point, you sometimes create the wrong impression that, oh, this project only deals with these use cases or these industries, just for finance, just for healthcare, just for, I don't know, communication service providers. So have you given any thought in the TSC and community about how
Absolutely.
to thread the line
It's,
between both?
it's a balancing act. You're totally right. But one pattern is there. It's a lot of people have questions that they want answered, and there's a massive data, whether it's your bug database, whether it's news articles, whether it's political sentiments. So a chatbot in some form is kind of like a very stable, important pattern. Like we all need a jacket type of thing. And whether that input to that chatbot is text, it's audio, or maybe even a picture. Like I show you a beautiful like cave scene, and I actually had a puzzle. It was a cave scene. Where is this place? I want to visit it. And it happened to be Turkey. Okay, there were like little cave, mountain dwelling, church like places. So I think chatbot's a good one, and it's one of our more complex ones. And then the other one's like it's a subsection. I mean, a subset of that. I don't need all the vector database. I just need to do document summary. Translation is also something that we all need. So we have about 14 examples, but even that you can really boil down to just 3 or 4: chatbot, document summary, and things like that. And with our relationship now with ByteDance as a partner, they're going to bring in some agents, and those will be things for like, how do I deal with information that might be in charts or in pictures or something? You have to process things a little differently. And in that scenario, I think our partner there, and also TSC members, Llama Index, who has many abilities to chop up data in these other formats. So we're trying to keep that balance in a few generic, useful examples. And then also because it's an infrastructure integration project, we'll have to deal with different hardware. So, I mean, we have our friends NVIDIA there, but we'd like to bring in more people and run these. And it's also resource. So we just run a few things on NVIDIA and see everything still works there. And then AMD, it's x86, so it's not such an issue. And then companies can then monetize by offering consulting services. They can even monetize by offering their cloud services and then optimizations on these models for their systems and things like that. We're keeping it open. And just yesterday I was even reading, what do we even mean by open AI? And like, is it the data and the model? Is it the model and the...
That's a bigger question.
Exactly. So we haven't answered that question, but we'll try to set
That's
the
a
stage.
price. Thank you.
Thank you for the question. I owe 2 people money. Okay.
Ask question.
Yes, please.
For the hackathon, is it like in person or is it online?
It's online, and we have a few community. So his question was about the OPA hackathon. It's online. It's a whole month long, so you don't have to stop, drop everything. And you can even choose bigger pieces. You can start with a few little baby items, and then as you develop confidence and get a little more sense of what you want to accomplish, you can do a bigger task. We'll have things that are like newcomer, first issue, good first issue. We'll have some help wanted issues. Like one of the things we want to ease this in part of democratizing AI is like, okay, you have a few cloud credits in Amazon. Can I just run this quickly over there, do something for a class project? So what's the easiest way? You have to go to that cloud formation, click, 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 maybe a template for that. That would be a nice thing. So if you're savvy with that, that's a nice contribution to make. Or if your favorite cloud is Google, for Google type of stuff. And another thing is Tina, at that hackathon, we really do invite people to try and take one of our pipelines, modify it for their use case. And many things come out only with your use case, like whether you use Milvus or whether you use VWeight or whatever. Your vector database depends on the volume of data you're using, how much time you have for processing, what's the dimensionality of your vector. And based on that size, do you want to use one form of indexing versus another? So those are the spaces where people end up playing to meet their use cases. And that's another thing where you write up a blog or you write an article or you provide that custom pipeline based on this use case. Like in your case, you had mentioned you were writing something for the library, and you can do it for all libraries in the US or whatever. See? or pull up the Wikipedias for all the oldest libraries in the world and where they're different. And so it becomes like that.
Awesome. Yeah, you're on time. Cool. The AI character MC, Fish.
Our first session after lunch will be led by Hao Su from Ayita, focusing on how Ryoma turbocharges data analysis.
Is he here? How's she? From FAI? Vanessa, you know him? Then we jump to the next. You confirm he's here? From which company? ATA. Oh? Yeah. How? Okay, jump to the next. Can you figure out where he is?
Not here. From online.
What's on? Let's move to the next while we're looking for the speaker.
Okay, just move to next.
We'll then hear from Jeff Brower from Signalogic Inc., who will discuss a small language model for on-device speech recognition.
Which plug do I use for?
Because under the table, you see there's a, oh, you mean to the screen?
Yeah, share the screen. I see some HDMI here. Okay, I'll get started. My name is Jeff Brower. The company is Signalogic Incorporated. We've been participating in Acrano, which is a Linux Foundation Edge project since 2020, actually since late 2019. Acrano is initially more telecom oriented. I think it came from AT&T and some other major players in telecom, but over the last couple of years, it's kind of moved to be more AI centric as the telecom energy kind of went elsewhere and the AI energy came into it. So Signalogic is now continues to participate in that and in the Infinite Edge AI, which is a newer Linux Foundation Edge project. So we started off in 2022 with the a robotics blueprint, and that was originally sponsored and incubated by Fujitsu, the primary leader of which is Haruhisa Fukano-san, or Fukano. Fukano-san is here, he's back there next to Wilson. And so he led that effort in 2022, and Fujitsu was partnered with the University of Ritsumeikan in Japan. I think they had some Japanese government funding and also, of course, some Fujitsu funding. So initially it was about food preparation, robotics food preparation, but they had a unique requirement that the food manufacturing personnel were wearing thick vinyl gloves. It's a very wet and slippery environment, so they needed hands-free commands. So that's where the voice recognition came into it. So SignalLogic was working on voice recognition at the time, and we offered to join their blueprint and contribute that part of it, which we have done. Since then, SignalLogic has continued, and we're more focused now on speech recognition for robotics. But that's not just factory equipment, but also, say, humanoid robot, robotaxi. But in these cases, what you end up with is an extremely difficult environment. So I'll get into that in a little bit. So the challenges that we see are, I guess, best described as difficult conditions. So the first problem is you don't always have a cloud. The first thing our factory customers will tell us is, well, this thing had better darn work if the cloud is out. If that forklift is going the wrong direction and one of my guys says, yo, stop, and there's no cloud, that thing better stop. And so anytime you have a safety or urgent command situation, you cannot tell the customer, okay, you're going to have this always on Linux instance somewhere in Amazon, and your speech recognition will be running continuously. Don't worry about it. So that's a non-starter. You definitely can't do that. Obviously, in a lot of cases, you need a very small form factor device, and I'll show you some of the ones we're using later. So as soon as you say non-cloud, then you start looking at whatever your bare metal is. What are you going to have there? Are you going to have a server rack, or are you going to have to go something smaller? And then, of course, you have operating conditions, environmental conditions. There's always a lot of background noise. Other people are talking. You have machine noise. There's robotics around you. There's servo motor. So there's a lot of problems that come up. So it's nice to say, well, we're going to do speech recognition, just like the previous Jose from Grok. He says, well, we're going to do the transcription 100 times faster. Those are in ideal conditions. If you've got a lot of errors coming, your speech recognition is producing errors because of the background noise and so forth, it's not going to be 100 times faster. So you're going to have to iterate and do a lot of things to make that better. So some of the use cases I've already sort of alluded to, but it's good to kind of formalize those. Manufacturing and factory floor are major. Those are probably our leading customer inquiries at the moment. First responders, now that's very interesting. We're actually working with a utility, a public utility here in California. They have a need, I'll talk more about the specifics of it, but just to summarize, they have a need to talk with, and I say talk, I mean literally talk with stalled vehicles, like a robotaxi. I think you guys might remember about a year ago, there's one that got stuck in concrete. I don't know how it did that, but now it can't go anywhere. The police show up, and whether it's connected to the cloud or not, or whether it just has a connectivity problem, the first responder would like to be able to tell it, okay, stop trying. You need to turn off, raise your hood, whatever the procedure is, and just needs to be able to communicate with that vehicle in a normal fashion. Not going to be any extra training for the police officer on how to whip out an app and type in some special commands or anything. He's in a hurry. So that's one of the things we've encountered. Similar situation would be with cargo, automated trucks. Anytime you, again, have an automated vehicle that gets into some safety-related situation, or the authorities are involved, then being able to communicate or converse with it in a normal, natural language manner becomes an issue. When we do this in the presence of these difficult conditions, we have two problems. I've already mentioned some of the noise issues, which cause inaccuracies in the word recognition, but you also have a precision problem. You do not want to be giving robots commands that are in any way unsafe. So you're really worried about false positive, like telling it to do too much or telling it to do something, telling the robot to do something that might end up being even more dangerous than the situation you're trying to address. So we really need our machine commands after the speech recognition, after cleanup through small language model and whatever else we're going to do. We need those to be as precise as possible and be as accurate as possible. They should be safe commands formulated for in machine readable format for the robot, for the ROS, for the robot operating system. So now let me mention the primary problem that we have. This is here, the sound-alike errors. And I've given an example here, and you'll see this example. I use it a few more times in my presentation. But this is a typical thing that happens. So you say something basic, like in the early days, a king ruled the state. That's what it's supposed to be, ruled. You want it to be ruled the state, but the ASR produces something else. And it's not off by much. Rolled is similar to ruled. I mean, it's obviously a sound alike, state, skate, slate. I mean, there's a lot of words that sound alike, right? And background conditions, inadvertent talking in the background noise, things can easily cause those things. We've tried all the models. We've tried Callie, we've tried Whisper. Anytime you start running these things in real time on a couple of cores, then this is what you get. There's no way to avoid it. It's a given. Asking the Callie guys to make it perfect and increase their word error rate by another fraction of a percent, that's useless. This is what's going to happen. If you think about the way humans do it, this is very normal. Someone says the word invoice, but you heard envoy. You have to stop and think about that a little bit. It takes you a while. You have to consider context, and then you clean it up, you figure it out, and you have the right answer. So there's not going to be a perfect ASR model. So we gave up on that a long time ago. And anytime I hear the guy saying, "Oh, we're making it better, please try our new upgrade," I'm like, no, your 2021 version is fine. We're not going to go any further than that. Now we're focused on what we can do as a post-processing stage. And that's exactly where AI comes in. And we start talking about reduced LLMs as a small language model. And that's the focus of Linux Foundation's AI and data project, is these reduced data models. So that kind of gives you a summary, why I'm here and why we're involved. So the current SLM state of the art, this is fascinating. I really enjoy testing these models. So if you give that same example in the early days, this is wrong. It's supposed to be a king ruled the state. I gave it the wrong. That's the wrong result. But if you give that to a Llama 2 7B model, it can't solve that problem. And I have a link here for the whole chat, and I've included most of it here, although it's hard to read in this slide. We recently tested it with Llama 3.1, 8 billion weights, and similar problem, no change. So it gets a wrong answer, and you keep trying to ask it to do better, and you start giving it hints. There's 2 errors in the sentence. Maybe you could fix the first error first. You start trying to guide it, and it makes various stabs at the problem, and eventually just comes back around in a circle and kind of starts over again. So it's not doing the job. But what we've discovered is, if you start refining your questions, if you start saying, okay, I'm going to give you a couple of possibilities, which one of these is more likely? Now you start getting more useful results, because now it makes sense. Now I can go back over this wide context, and it can say, statistically speaking, I haven't seen a king roll very much of anything. Did it roll the dice? Maybe. That's about it. So you're going to get a better answer if you can actually submit possible sound-alike errors. But there could be dozens, there could be hundreds of those. So how are you going to get those? So that's the specific problem that SignalLogic is focusing on. How to come up with an intermediate stage. I'll show that in a data flow diagram in a minute, that sits before the SLM that identifies likely possible sound-alike substitutions. And then we submit that to the SLM, and we can do it iteratively. That means we need a very fast SLM, and we're trying to run it on just a couple of cores at the edge. So it's quite a challenge. But the whole idea is that you're going to narrow the context window down. You're not going to need a, multi-dozen, 100-word, 1,000-word context or article length context window. You're just going to need a few words because you're just looking for statistical likelihoods in the English language or whatever language for the probabilities of words being adjacent to each other. So functional requirements, I mentioned some of these, but I'll cover them again, or just briefly. We want to correct these sound-alike errors, but the important point here is, at least in terms of Linux Foundation, we want to stay independent of the ASR model, and we want to stay independent of the SLM. So we can try different ones. We can swap them in and out. We can do test and measurement. If somebody says, well, I've taken this Llama 2 model and I quantized it, then okay, no problem. We can swap it out easily and try something else. So this is the basic data flow, and this is where we're focusing our efforts. And again, we need to be in real time. This is real-time speech recognition for factory and first responder. And so we need to be processing tokens relatively quickly. And we want to have multiple iterations. We want to be able to, we want to not just say, okay, we're going to run this one query, and in 100 milliseconds later, that's it. We'll run another query. No, we need to run many possible queries in that 100 milliseconds. And we may end up with some of our own decision logic, making like a consensus pick or something like that. But the SLM has to be very fast. So one other thing that's interesting in functional requirements is there's an emerging standard for teleoperation with robotic vehicles. So if you have a stalled automated vehicle, then will be, it's not finalized yet, but there will be a way for the authorities to authenticate and then communicate with it. So if they have a portable speech recognition device, then they can talk and the output will go, say, to a USB or Wi-Fi, and that's how they'll communicate with the vehicle. So again, no cloud necessary. The standard isn't formalized for that yet, and it's kind of slow, but they are working on it, and they do see the need. I would probably guess that maybe some of the Waymo and some of the other robotaxi people working on it are not, this is not a priority item yet, but soon enough, there will be some accidents, some things will go wrong, and it'll become a little higher priority. There definitely is a need for that. These are some examples of the hardware we're currently using. So we're running it on a quad core Atom with 4 x86 cores at around, I think, 1.2 gigahertz. And we've also recently started working with a quad core ARM. It's actually got 8 cores, but 4 of them are more for media rather than general processing. And so this is the type of hardware that we need to make it work on. 15 watts or less, run on battery for, say, 3 hours, something like that. It can be in a small container, doesn't need a fan. We'll be using convection cooling. So you can see the resource constraints make this a very challenging problem. And you can see why the SLM needs to be, when I say S in SLM, I mean small. It has to be small. Of course, the first question is, and I get this all the time, is why not use a GPU? And it's a really good question. And I don't mean to disrespect NVIDIA or anyone else, or Grok, or anyone making fast makers multiply. But the problem is, one of the first problems is, although it might functionally meet what you need, its processing rate might be, 1 token per second for a Llama 2. Its power consumption you might be able to get under 15 watts. But again, we need ultra speed. So we're going to take a model that gets compressed down to 8 billion weights or less, and it's going to be quantized, and it might be have a very small context window, and it might not be doing anything that you expect out of a chatbot. It's not going to be that good, but we need that because we can make multiple queries, ask it to consider multiple possibilities, in that 100 millisecond time frame that we need for real-time speech recognition. So speed becomes an issue, and I know NVIDIA is fast, but it's to run it on that and do what we need and have that flexibility doesn't seem like a doable thing right now. And we're also need, of course, additional CPU cores anyway, because we have to run input might come from an RTP source, like a codec, like EVS or AMR or something like that. We also have to classify audio and do our best attempt at noise removal. So we need some general purpose signal processing that you typically wouldn't run on a GPU. So that's the reason, those are the reasons we're not using a small form factor GPU, at least not yet. Okay, and I think I've already covered this, but just briefly, I'd like to emphasize that we want to keep the solution general, and we don't want to tie down to any particular ASR model. Here's a data flow diagram. I gave one for robotaxi and one for language translation. So this is where we're doing some signal processing. This is your ASR model. This is our focus of our effort. This is also a focus of our effort, but we're not in the business of training models. We'll work with whoever model we think that can do the best job. We talked to one recent startup called RCE, RARCEE, who kind of seems to be more interested in these edge use cases than some of the other vendors. So people are starting to pay attention to it. And of course, more general purpose processing here to formulate precise commands and finally issue the robot APIs. It can also be used for language translation, although we don't have any customers asking us about that right now, but the thought occurs to us that it's a very similar problem because you need, before you go to the other language, you want to be as accurate as you possibly can. So again, precision is an issue there. Your errors might accumulate if you don't do that. So here's a little bit more about our algorithm. This is it may be too detailed for the talk here, but I thought some people might be interested in it. So what we're currently doing is we take basic words. I mean, these are tokens if you think about it, language model training, but words. And so that's your normalized starting point. We all know the words in the language. We run them through text-to-speech, and we run short-time Fourier transform analysis on this. And then we do format tracing. Now, this is basic stuff. It's been around for years. But the idea is to create an image, a very simple image recognition problem. And then from that, what we're trying to do, and this is one of the more philosophical goals of our R&D effort, we're trying to stay away from the need to train and or end up with an inference where you need a lot of matrix multiply. Because obviously, if we're using CPU and not GPU, that's going to be a requirement. We don't want to burden that one core or two cores that we have available with a lot of matrix multiplies. So the training method that we're using is something we call proximity addressable memory. It's somewhat similar to content addressable memory, but in this case, the address also matters. So you can think of it as you're in a 3D memory space, where if you stand there and you look around, things that are close to you are related. So if you say the word state, and maybe there's other possibilities like slate, skate, etc., they're going to be close to you. And so the search required to find those alternative words is very fast and efficient. So you can find the words that are close and then submit these possibilities to the SLM and come back with a statistical likelihood of which word sequence is probably correct and help you with the precision problem in the speech recognition. So the inference that we do, I've explained that as asking the SLM which of these possible words is more likely. So the idea is to refine your query and don't stop thinking of it like a chatbot. Stop thinking of it like something that's always going to give you one query with a perfectly good answer. In the real world, that's not going to happen. And in fact, we just saw the previous speakers talk about iterating and getting a better answer. And I think that's really going to become something that people talk about more often with language models. And if you're not confident of your answer, if you're a little bit uncertain, you keep asking. Of course, that means you need more queries, more speed, more time, and that's one of the reasons why we're focused on finding ways to make this whole process faster. So here's a little bit more about the PAM, proximity addressable memory itself. The concept's been around a long time, since the early 1990s, but even then, it was intended to be used with neural networks. So we need to be careful. I have a saying I like, it's called smarter than your grandparent syndrome. A lot of times society, we exhibit that. We think, oh, we know better. But if that were really true, right, we wouldn't even have these language models today. We wouldn't have the explosion in AI. The concept of neural net's been around. They had the perceptron in the early 80s. They just couldn't get it to work right because why? They didn't have enough horsepower. They can't process enough layers. So these things are not, some of the research that people have done in those time periods, you have to be careful just to dismiss that. It should be reviewed thoughtfully. And so this idea of a proximity addressable memory has been around. Wasn't much done on it between 1990 and still a few years ago, but now interest is being revived. And I've got a few citations here. You can get the slides off the wiki page, the Atlassian wiki page, and you can start to look these up. So people are starting to pay renewed attention to this. And let me just stop at this moment and I'll digress a moment. So you think about this again from a philosophical perspective. And again, I don't want to disrespect NVIDIA or any other big techs, ByteDance even, or anyone who's here today, but when you think about these huge models, I've heard some of the speakers talk about carbon footprint, but my goodness, what about the water? Where is all the water going to come to cool these huge data centers? If evolution thought that centralized intelligence was energy efficient, it would have done it. It didn't happen. So energy efficiency is prized. That's a key objective. Evolution over millions of years has made that abundantly clear. So the fact that we're just throwing energy efficiency away and making these huge supercomputers, gigantic cabinets full of GPUs with no thought given to energy efficiency, I think eventually we'll conclude that's the wrong path. Certainly, practically, it puts a lot of pressure on people to find the alternative. If you can't afford that $10 million that Sam Altman was talking about, then you got to come up with your own method. Even here in the US, SignalLogic is a small company operating out of Dallas, Texas. We're not going to go buy a whole bunch of GPUs. We're not going to pay Amazon or OpenAI, I don't know how many hundreds or thousands of dollars a month to run on their GPUs. We don't even know exactly what works yet for our problem. So we're going to find a different way. And if that's happening here in the US, you can be darn sure that's what's happening around the world. But people are looking at this saying there must be a better way. So from a philosophical perspective, you look at the human brain and you say, well, that's consuming 40 watts. And this latest rack that Jensen demonstrated at GTC back in April, that's a megawatt. And he's standing next to a refrigerator-sized rack that's consuming over a megawatt of power. There's something that's not lining up with that. So you get to the underlying root cause of that and you see, well, it's the training method. You require gradient descent. You require back propagation that requires a high level of numerical accuracy. That's what takes your energy and all the data movement. But clearly in the brain, that's not what's happening. We have nowhere near the level of power. 40 watts is not going to support even 4-point FP4 precision on matrix multiplies. That's not happening. So something else is going on, and part of our company's R&D objective is to find practical answer, but keep our eye on that long-term, keep our eye on the ball from a long-term perspective, because that's probably where things are going to go. People are going to start worrying to a much greater concern or level of concern about energy efficiency, not just for carbon output, but also for water usage, for yeah, cooling and the safety issues. I mean, you put all this in one spot, it becomes a target for who knows what. Decentralizing the AI in the cloud is a long-term trend. So when you see someone like me come here and talk about a new type of inference and he labels it proximity addressable memory, you have to think about the why. There is some rational thinking behind that. So our current status is we've got a lot of things working. We even have speech recognition demo up using our software. We're doing that on a quad core Atom board. It has a 20,000 word vocabulary. We're using CALD SLR, or excuse me, ASR. And that's one, achieving all these two things right here are one Atom core. It's running in real time. But of course, like I said, under difficult conditions, it's producing a lot of sound-alike errors that we need to fix. So the status is okay, but we need to continue development and we'll continue working on our sound-alike detection method and testing that. And at some point, we'll figure out which SLM that we think can be small enough and fast enough. And we may end up training our own, but just using open source tools to do that and reduce the context window. And although you can't ask it very many questions and have a dialogue, you can get statistical likelihoods for word sequences, which is exactly what we want. And eventually we'll do a live demo with a Pico ITX form factor board. Not now. I wish. It's a hard problem, Tina.
What problem?
Yeah. Okay, does anyone have any questions? Yes, Melina.
There's a lady also from the robotics company, right?
So Jeff, this is nearly like 12 years ago. We had 96% speech recognition accuracy. But what we did is we said, what domain? This was a company called Dragon and Nuance. So
I'm very familiar with them.
Okay. So with the radiology domain, like, bone broken, something. So we basically trained with my voice or his voice, 10 paragraphs and then 96% accuracy. So maybe you can do a little training with each person's voice or a smaller, like what happens in a factory floor and get away with a much tinier one. That's like 12 years old technology. Have you all thought about that?
Well, yes, but we need something very generic because we don't know who the factory workers will be and what they'll say, whether they'll be speaking under stress conditions. And it doesn't take much. It really doesn't take much to throw some of these models off. If it's accented English, they're yelling, they've got mixed in with swear words or something like that.
Yeah, we had to train for that too.
Yeah, it's difficult. So it seems inevitable to me that you must have a second layer of context-based processing. And of course, the progress that's been made with language models is very impressive for that. Although I disagree, as I pointed out, with the fundamental approach of applying these water-hungry, emission-hungry GPUs to it. They do work. The method does work. So why not use that? But we're going to have to use it in a very reduced form, very fast and efficient form. And I think that's an approach that may show promise.
But even the vocabulary can be smaller.
It could be a little smaller, but I don't want to be telling our first responder customer, your police officer should not use the full range of the English. I really don't want to put any conditions on it. The ideal demo for us is they get their most rough guy who is known inside the department or maybe inside the fire department as a man of few words or something. But when he talks, everybody listens, and it's he's got a gruff voice or something, and he says, "That stupid car, and get off the road." And it works, right? No questions asked.
Thank you, Jeff. Interesting work. Since your core idea is the idea of generating sound-alikes and
Fixing them, yeah.
Fixing them. I was wondering if that could be tested in less adverse conditions. For instance, when we are making the order at a restaurant window, or at a McDonald's, that itself is a unsolved problem.
Yeah, well, that's exactly what we're doing. The testing that we're doing right now, we just run all kinds of, you can do essentially impairment, deliberate impairment, right? You can take accurate output from the ASR and you can mix in all kinds of wrong words with it and then submit it to our algorithm for test. So yes, absolutely.
So what is the state of the art if you did not have the power constraint or the processing constraint?
Oh, then if you used, like the example I gave in the early days, a king ruled the state, if you go to ChatGPT 4, it will fix it. You can give one query, wait maybe a few seconds, and the answer comes back, and basically it's right, and you don't have to sit there and refine it. So it will, based on its statistical knowledge of all the articles in language, ever spoken by mankind, it will figure that out. And that makes sense. It should. It absolutely should. But you're not going to put that in a backpack. And I think I skipped over one slide, but let me back up and just mention. People often ask me, well, why wouldn't you just do this on your phone? And maybe again with a phone in a cloud and ChatGPT 4 you could. But when you go to factories and you go to first responders, like ask yourself why. For example, do police, when they wear a body cam and they record audio and video, why is that not done on a phone? Does anyone know? It's done on, I can tell you, it's done on a device. And when they get back to the station, they upload it to some proprietary equipment they purchased from a vendor. Does anyone know why that is?
Security.
That's right. For privacy and security, they have to have total control over the chain of data, right? It's like tampering with evidence. If there was any way for someone to get in the middle, man in the middle type of thing, it goes to court, it's out the window. So it's a very similar situation. You're going to have something like a backpack, a device is in it. It has to be small. Yeah.
Thank you. I guess, I was thinking security actually before you mentioned it, but isn't that a problem when, when you have a police officer walking up to a car and giving it command? Like, how does it know?
That's the teleoperation I mentioned. Let me back up. You have to authenticate. That is a weakness in our situation right now. That standard isn't formalized yet. So people are doing different things, but the basic idea is that you have to be legitimate. You come up to that vehicle and you've got to authenticate and issue some series of handshake, and then you can talk to it. You can talk, like if you have your private device, you can make sure nobody else is around you. You can give the commands, and they're being issued by Wi-Fi through an encrypted Wi-Fi to the vehicle. But again, not without. The key there is that if the cloud is down, if the cloud's not connected, all of that is still going to work, both from the first responders' perspective and from the vehicle's perspective.
But doesn't that doesn't it make more sense to add the IP address or whatever of a phone and say that's a secure phone and connect? It seems to me that's less of a.
Yeah, well, you can try telling that to the police. They don't want any, when we talk about phones, one of the first things they'll ask you is this, if we're going to put something on a phone, whose phone is that? Is that our department issued phone, or is that the officer's personal phone? So it's really an area where they tend to not want to go.
Oh, hi. Thanks for the presentation. I have one question here. So in one of the slides, you mentioned the current SLM being Llama 2 that we have tested, right? And then you also mentioned at the end of the slides that the ongoing effort will be continuing testing different SLM and to figure out which one you will apply.
Yeah.
So would you say at the current state that this is a already working solution, or this is a prospective project?
I think with Llama 2, we'll probably, I'm going to guess that our live demo probably will use Llama 2, like a 7 billion weight demo, but only if we may have to retrain one that's fewer weights, only for speed, just because we're going to need to make a lot of queries in that 100 milliseconds. So if we have that working on, say, 2 x86 cores, then we'll be good. And it will, that, I think it'll be enough to help us solve the problem.
I see. So that like basically the next step is we need to test it actually on the hardware to see if it
That's
actually
right.
works, right?
Yeah, that's right.
Because
It's like you down, like now you can download it and run it on your laptop. And depending on which laptop, it may be fast enough and maybe not. And so that for us, we have to, like if we run, say, Ubuntu on this x86, quad x86 small board, then we would download the Llama 2 and see if it's fast enough.
Thank you.
That's it?
Yeah. You can announce how here? How should? Oh, okay. So the AI turn. You accidentally cancel today. What? You accidentally cancel our last meeting today because a lot of problems with the online participants.
Our first session after
You were scared. Sorry, there was some news.
will be led by House.
I have this.
I got that also.
Oh, turn off the microphone.
It is. Yeah, that's probably right.
Do I just press this?
From Ayita, focusing on how Ryoma Turbo.
Something's picking it up.
Yeah. I don't know if it's this mic.
Maybe the computer?
It's okay. I will just announce the next speaker is Haoshi from ITS. You want to come over here? Is Haoshi from online or?
Online.
Oh, online.
Oh, hi. Hello, everyone. Can anybody hear me?
Yes. Yes.
Cool, thanks. Hi, everyone. I'm Hao. I'm representing IT team to do the presentation online. Sorry, we are not be able to like make it in person. I'm currently traveling. But we will be like also doing a lot of like collecting a lot of feedbacks from offline, and anyone want to talk to us, feel free to send us a email message or like from the Slack channel. Cool. I'll get started for the presentations. Cool. So we are ETA. We currently have around 4-5 people working on the project. A little bit introduction about the team. I'm Hao. I'm currently an engineer at JP Morgan. And we also have Fang from Morgan Funding. She's a data science manager. And we have Francisco from Red Hat as engineers, and also Mark from PayPal and Sushama from Dropbox. And the project is coming from more like a simple real world problem. So as engineers working in mostly in the data domain, we work with data scientists and analysts day to day on a lot of problems. And they pretty much asking a lot of questions about how they can gather the data or use the data. For example, for my like real use case, it's like our stakeholder would ask me, can you please share me with the sales data in the last month or in the last year over the last quarter per weeks? This kind of ad hoc queries are pretty simple to write, but sometimes like as a PM, they don't directly know how to write the queries, or sometimes like analysts or data scientists, they don't know where to query the data, and or like the schema, she doesn't know about that. So with this kind of
questions, we have to spend a lot of time to reply them, write the query for them, and if if it's just like simple few users asking the question, that should be fine. But as the team grows, more and more people asking this ad hoc request, it kind of be pretty painful, like taking a lot of our daily resources to answer the questions. So we want to explore the LLM to help on this case. So instead of like we write the queries, we can have more like a customer server, AI assistant to answer the questions. In the screenshot showing like a pretty simple use case, like when you ask the question, I want to get the top 5 customers which making the most purchase, the agent would be just responding with the following questions, following answers with the SQL queries and also a short explanations. And so we're also trying to plug in with the data source access to the agent that it can directly query the data, return the result if it's granted with access. So comparing to other services, so why don't we like directly using other or some other vendors? The main concern is more like I think a lot of sessions has talking about is data privacy or regulation concerns or permission concerns. So if we give the vendors our data, it's kind of we don't know how they're going to use it. Even though they are thinking it's much in the PI data doing a lot like data cleansing. We're still unsure because it's more like a black box to us. So instead of like giving raw data to the third-party vendors, we can just give the safe instruction to the agent to be able to write the queries. So from the knowledge database, we do some processing and to get the schemas of the table and feeding into the LM agent prompt that we when it's call the API to the LM like models, it can pretty much understand the schema on the table, but also without like real data in it. So this is like currently designing of the system. We are building on top of like 3 major components. One is like LM agent. We're using LangChain to do some of the orchestrations, such as calling the models, building the prompt templates, connecting tools with the data source, and also embedding the data to gather more related tables or queries. And the left bottom components is more about retrieval augmentation generations. We're leveraging Feast as a like feature store to orchestrate the embedded embedded vectors as well as the databases. So when for example, when the people ask a question, like that will be a like process to pull the related tables or related database or tables from the RAG system, and then like feed it into the prompt before actually evoke the LM models. And on the right side is more like about how to directly query the data and how to extracting the metadata from the data source. So to query the data, we started something new with such as like IB's like data frame APIs that runs on a lot of backends such as DuckDB and Postgres, Snowflake, and we also are trying to leverage some of the Linux projects such as Monson and Unity Catalog to give us the data catalog data, which is like metadata about the your data source informations. And so agent is more like our core component. It controls how you want to write, use the prompt, and how your conversation is saved as memories, and what kind of models you want to use, and what kind of tools you want to use, such as query the data, and outputs, like more like formatting the output, and retrievers is more like how you connect with your rack system. And we're also working on customizing the agents with a workflow. I think that's supported by the LangChain, that you can use the agent to call the tools and with some different workflow you want to customize. And so to build the workflow example is just like pretty straightforward. I'm showing the line graph. It will create like a workflow graph, state graph, and define your core model like process, as well as like build tool process. That way we'll instruct the agent to how to call the models or how to use the tools. And tools is basically like a calling of functions. So some like built-in tools we wrote it like how you want to how you can query the SQL database directly, and how you want to execute pandas expressions, convert to pandas or different data frame system. And to can also read or write data from data source. This is like defined as like functionalities. Well, since we are leveraging the LangChain's framework, so we pretty much inherit all the base tool module and override some of the like functionalities. For example, the SQL query tool would be like connect to the data source, execute on your query, and the result format you can specify is retaining as a pandas, arrow, or polars format. Prompt is something like when you feed or evoke the models. This on the right is like a built-in prompt template. It's like SQL template with 0 shot and similarity based on Euclid distance question mask, which is something I'm not familiar with. Like QA is like the format of the prompt template. It's like a question answering. So the whole prompt would be look like given the following database schema, since it's a SQL format, it's giving some of the schema in SQL format that's like create table, stadium, create table, singer, create table, concert. And with this schema such as stadium ID and location name, and with this schema context, and also like yeah, this one doesn't have the rag, so it's like only the schema context, and answer the following question: what is the average minimum or maximum age for all the French singers? And yeah, this like more like a built-in template. There are also some other templates like few short example template, which has like like some example queries in the prompt and like to instruct the LM to answer the questions. So vector store is like storing your embedded embedded data as a feature that can be used to help your LM to answer the questions, such as you have some of the written queries already, and you can like use the vector store to embed and store it in the database. And when the user asks a question, it can first to retrieve the similar queries and in your response first, and then feed into the invocations. So we use Feast as orchestration because I feel like the vector is nothing but a special features for LM use cases, and comparing to other vector store system like Haystack and LangChain's built-in vector store, they don't have support like this registry layer that you can register different like embedding data, which is pretty helpful for you to manage how you want to query the data or what kind of data you want to query before calling the LM. So currently, the phase supports like Postgres, SQLite in Elasticsearch, and we're working on more such Milverse and Quadrant to support more like vector as an online store. But you can also have set up pipelines from the offline store to onboard more embedded vectors into the online store. So data catalog is something important in our applications because we needed to help the LM to answer the questions with your like data schemas. So it when we're using we were building like this kind of framework, we're trying to leverage some of the popular Linux Foundation project. So found like Amundsen gave us a lot really helpful in this kind of utility. So this is like screenshot of Amundsen's project. So we talked about like so said like it giving 3 types of informations for the metadata. One is application context and behavior and change. And this kind of information are really helpful to instruct LLM to how to use the like data schemas to to do the invocations. So this is also like a relationship of the like data catalogs, how the table, schema, columns connected together. So on a high level of the technical stacks, we started with like a Python reflex to build the application layer. It's a pure Python framework. And so with LangChain to build a like call agent library, and Arrow IBs to build the data source, and Feast to integrate the vector store systems. So something development is also about like the workspace. Like when we do some like experiments with our the scientific analysts feel like it's also really important like for them to be able to modify the queries or experiment the queries. So we also integrate or created like a more like a notebook environment that really the user can modify the queries as returned by the LM, and also keep interacting with the LM on the result. So yeah, this is how currently 3 teams are in the companies are using the ITA, and we also get some sponsorship from other accelerator programs. And we are still at pretty early stage, only like started development recently. And we want to get more people to contribute and get more feedbacks to like direct us in a good direction, how we want to build the product. And also there's still a lot of work. It's like currently it's pretty much not a scalable system. We more like do a lot of local interactions and no deployment on the cloud system. But that's something we are planning to do in the future. We also need some of the robust testing, missing a lot of automations as well. So yeah, if anyone is interested, feel free to reach out to me, our team. We are also a sandbox project under the Linux Foundation Data and AI. We recently renamed it into Rioma. Feel free to reach out to me in the Linux Foundation AI data Slack channels or like directly post a question on the GitHub. Cool. I'll stop here, see if anyone has questions.
Probably we cannot have like the question like today because the way that we connect if like we say anything then it will be echoed. It will be it'll be you won't hear anything. So today let's give me a second. I think we will have the next person introduction.
Next, Deborah Dahl from Conversational Technologies will present a fascinating look at teams of AEs and conversational assistants that can communicate with each other.
Hello, can you hear me?
Hello, can you hear me?
Yes.
Yeah.
Okay. Well, I'm going to be talking about teams of AIs, how conversational assistants that can talk with each other. My name is Deborah Dahl, and I'm from my company is called Conversational Technologies. I'm working in the LFAI and Data Foundation on the Open Voice Interoperability Initiative. So what our group is, Voice Interoperability Initiative. There was an original organization before us, and it was called the Open Voice Network. Since almost a year ago, it's become a project of the LFAI Data Foundation. We're trying to revolutionize the conversational AI landscape by enabling voice and conversational AI systems to function like the web. That is a future where users can seamlessly interact with any assistant or language model using a standard messaging protocol, standard API. That's going to let assistants interoperate across platforms, however they're developed. They could be like an Alexa or Google or Microsoft platforms or open source platforms, letting the assistants communicate with each other with just seamlessly and transfer content. I think we probably mostly know what conversational assistants are, but we can quickly define them. Software systems, they're software systems that interact with users using natural language in the form of speech or text. So chatbots or voice bots are similar, are examples of conversational assistants. And they're just like any software. They can do all kinds of things, interacting with users. They can answer questions. They can store information that the users are providing. They can entertain you with music and videos, and control the physical environment, which is what we often will call the Internet of Things. The difference between most software and conversational assistants is that users and systems interact with natural language. So what we're trying to make possible is collaboration among different intelligent assistants. So there are millions of existing chatbots and voice bots in the world. They're hosted on all kinds of platforms, mobile phones, smart speakers, and websites. And they're hosted by many organizations, governments, businesses, nonprofits, and even plenty of them are developed by individuals. They're all silos. They're all independent of each other. Even the chatbots within an organization are pretty much self-contained and not able to interact with each other. They all have their own expertise. And so what this ends up being is a situation that we have now where the implementations are very complex. If two different chatbots need the same expertise within a company, for example, two different HR chatbots both need employee information. Their data needs to be duplicated. And that causes a lot of friction for users because users are always having to go from one chatbot to another. So we kind of have two broad categories of use cases. One is that chatbots deployed by large organizations, like businesses, governments, or universities. They have a lot of different functions, a lot of different expertise. Businesses, well, I guess governments are probably the biggest example. Governments perform dozens and hundreds of different functions for their citizens, and if they can cooperate, they can tell you, they can send their users to different different chatbots as their queries change. So for example, in the United States, the user could be talking with the IRS system, the tax system, and then have a question about related to their Social Security. And so the IRS system doesn't have to duplicate that Social Security information. It can just send with a collaborating chatbot, would send the user to the Social Security chatbot. The other major category of use cases is users accessing the chatbots for vendors where they maybe as an individual, you have many vendors that you deal with, pharmacies, grocery stores, the government. And then it would be nice to be able to just talk to your personal chatbot and have it help you check to see if your prescription is ready at the pharmacy. So we see the interoperable intelligent conversational assistants as being a network, almost like the World Wide Web. And one thing that we can look at, look on the left, we have a user who might be interested in talking to the pharmacy. They talk to the chatbot that's part of the drugstore chain. And the user asks a question about their prescription that could be sent to a chatbot that knows about drug information, like the FDA or the CDC of the United States. Then they want to know if their prescription is ready, and without ending that conversation, they could go to another conversation where they can actually find out if their prescription is ready, how much it'll cost, what are the hours of the store where they could pick it up. So we also have, wasn't quite finished with that. There are also similar cases with some kinds of robots that you can talk to, even robot pets. It could all be accessed through this web. So what we've been working on are some interoperability standards to try to make this vision possible. Our standards are open source. They support dynamic real-time configurations of the AIs. They don't have to be pre-programmed that I can talk to this chatbot and that chatbot. It's like the web where you go to one website and then you can go to another website. It doesn't have to be pre-programmed. The key to all of this is standard messages that the chatbots and conversational AIs can use to exchange information, make no assumptions about assistance architectures or internal structure. They can use any language model or even rule-based systems. It doesn't matter. They're black boxes. Their only capability that we assume that they have is ability to interact with natural language. So we have implemented a sandbox implementation of our standards, and we have specs in our GitHub repositories, and they're at the URL on your screen, Open Voice Interoperability. So just to delve down a little bit more into the types of messages that we've designed, we have three big categories of messages. One is the assistant manifest, which is enables a conversational assistant to describe their capabilities, what their knowledge is, so that another assistant can say, yes, I want to send my user to this drug information site, for example. The conversation envelope is the big one that controls all the actual connections between the conversational assistants. Makes the connections, allows them to exchange information and conduct conversations, and then finally end the interaction. And the other message category that we have is dialogue events that are the way that we represent natural language utterances that go between the user and the system. How do you become an interoperable chatbot? It's not very hard. You have to be able to accept the incoming invitation message. That's one of the conversation envelope messages from other chatbots that invite you to join a conversation. Once the invitation is accepted, the chatbot has to accept utterance messages through the conversation envelope in the format of dialogue events. And then those might be messages from a user, and then respond to those user utterances. And then when the conversation is finished, it has to be able to end the conversation. That's the minimum. So there's really, I don't know, maybe 4 or 5 message types at the most that you have to be able to accept to become a minimal interoperable chatbot. So here's just kind of what one might look like. This is part of a conversation envelope messages that carries the a message to some website. It's an utterance. It has a speaker ID and a timestamp, and basically it has the utterance, "I need my repeat medication." All of the messages in all of our formats are all JSON messages, as you can see. We have a sandbox implementation, which is very cool. It's also found in our GitHub. It's based on front end. It's a web page front end with JavaScript and the message the message creation and parsing is done in Python. So the next step, I told you about the minimum interoperable chatbot. There's some more features that a chatbot could adopt to become even more capable. One is publishing a manifest that describes your capabilities, that lets other chatbots find you. That uses the assistant manifest specification. The minimal chatbot only gets invited by another chatbot in response to the invitation, but the chatbot could also send invitations to another chatbot, and then this could keep going on as the chatbots need to draw on the expertise of the of other chatbots. And then finally, excuse me, the other capability that they could have is to actually be able to use the manifest and find a chatbot with desired capabilities. And that, of course, is going to remind you of a search engine. So basically, that's sort of modeling the web. Search engines can find web pages with the desired capabilities in the same way. Some of the things that we're working on now are really interesting. The one that we're probably going to be ready to publish pretty soon is where chatbots can participate in teams of chatbots simultaneously in a shared conversation. So everything that I've talked about so far was kind of like a sequence of a user being transferred from chatbot to chatbot as they needed the expertise of the different chatbots. But we also can see some use cases where the chatbots all need to be gathered together and talk to each other and the user at the same time. So we're developing some new messages, probably 4 or 5 new messages that we use to make that kind of use case possible. We also are looking at enabling messages. So far, the messages only really contain one utterance, but sometimes a chatbot might need some background information to pick up a conversational thread and talk to the user. So we need to add some capabilities to the messages that provide the context in addition to just the utterance, so that the chatbot on the receiving end can understand why they're being talked to. So a good example of that would be, I'm sure you've all experienced this in a call center where you get a transfer to an agent that you need to repeat your name and your question, everything that you just told to the previous agent. We want to make that not necessary in this interoperable chatbot world. And then, of course, if we're passing data around among chatbots, if there's security concerns, a lot of information needs to be secure. We want to make sure that authentication and private user data aren't compromised. So those are some of the things that we're working on now. So I would be very excited to invite you to try out the specs. You can use the sandbox, or you can start from scratch. Some of our users have not, some of them are bootstrapping off of the sandbox, and other ones are just starting from scratch. And if you you saw that the one message that I showed you the example of, it's pretty easy to implement that message. We love to get any feedback, and we also, if anyone is interested in joining us and working on to define the specs, that would be really great to have more participants. So here is where you can get more information. This is just the Open Voice Interoperability GitHub project. And that wraps up my presentation. Thank you for your attention. And if anyone has questions, I can answer.
Deborah, are you in San Jose or somewhere outside the Bay Area? Can you hear me?
Echoes. I think if you say it, then there will be echoes. So I think probably we just.
I guess we're going to have the problem of echoes.
No, it's not a question. I'm just wondering why you're not here. Are you outside the Bay Area, Silicon Valley?
I can mute my microphone if somebody wants to answer a question and then come back.
Any questions? Yeah, no questions? Okay. Yeah, I think we know this company. Can you hear me? Shall I unmute my microphone for my here? Let's see. Can you hear me? Yeah, it works. Okay. Wanna use this?
Hello? Can you hear me now? Okay, perfect. Yeah. I was asking.
Yeah, so can you hear me?
No, she won't be able to hear you. whenever she hears you, there are echoes.
Oh, you wanna try this microphone?
Maybe you can move.
You know what you need to do is turn off the speaker that we can't hear her while she's talking, then turn on the speaker. You know what I mean?
It will be a little bit difficult, I think.
Okay, never mind. Hello? Oh, is this running out of battery? Did you try yesterday night? Did you try yesterday night? Did you try?
Yeah, I tried yesterday.
Hello? Okay. Yeah, maybe I'll text you offline about the questions. Yeah, okay. Thank you, Deborah. See when she can hear us.
That brings us to the end of day 2. Thank you all for joining us over these incredible 2 days of collaboration, learning, and innovation. We hope to see you again at our next event.
It's 3:30, right? Yeah, 3:20. Our happy hour is actually at 4:30. If you can wait that long, but yeah, and mingle here and whatever, and then you can leave.